Hello everybody, welcome to the stream. Stream. Stream happen? Stream. You can hear me. It's a good sign. Go ahead and pause that and hope that everything goes well. Let's make our little announcement. And yeah, we'll get right going after this. Compiler part 44. No, 34. Woot woot, we are live. Welcome everybody. Saraid says, yep, what's going on, Saraid? I've been keeping track of your IR branch. It's looking beautiful. I'm starting to understand, Saraid. Thank you for being so convincing and caring enough to make it happen. We will all grow as developers because of it. Okay, let's go into Fun Compiler. What are we doing? Let's just look at the docs that I was writing. So, you know me, I wrote more LaTeX. That's my style, apparently, now. I even have the language name as its own command, which is pretty awesome. King Buns, what's up? Brainsman says, what up? Saraid says, still working on register allocation. I think it's about halfway done now. You're very much, you're like 90% of the way done, but you're halfway done with the work, because the last 10% is just as hard as the first 90%. But it's looking beautiful. I'm starting to understand Chaitin-Briggs too. Okay, now if you don't know, LaTeX is a fancy markup language that is made for like making printable PDFs. I just like it because it looks like professional and you can print out anything that you make. And generally there's a lot of tools like Pandoc and you can convert it into other markup languages and or convert other markup languages into it, and there's all sorts of things. And you actually compile this into a PDF. So you use PDF latex if you're using Mictex. You can also use ZTeX. You can use eTeX. There's so many distributions. I just use this one. It's like C compilers, right? There's a million. Pick which one you want. But I use PDF latex, and then you just feed it the tex file. I know I say latex too much. If I am reading this, I'm gonna say latex. But if I talk about the language, I'll say latex because I remember. But it's hard for me to remember when I just read the word latex. So it says, are you gonna do some algol today too, maybe? Maybe. We'll see what we get to. We can do anything. And here's the output it produces. If you didn't know, Emacs is a PDF viewer as well. Has a whole doc view package built in. And you can see we built this just now. And so as an overview, Intercept has 3 stages, or phases, or levels. And anything to that regard. We'll call them stages, right? And that is parsing, type checking, and code generation. I'm sure we all of us that are here are familiar with this. This is just for anybody like a new developer who's like, what the hell is a compiler, right? So hopefully this helps them get a broad overview of like what we're even talking about and where things happen. And I may want to add like source code and executable like on either side, but it's not exactly proper because code generation can make anything. And in our case, it'll never make an executable. We're not going to do like system calls, so I don't know. We'll see how it goes. Anyways, we talk about parsing, which has a lexer. We give examples. So like given the following source code, the lexer would produce the following lexemes, which are basically understandable chunks, right? They're basically an arbitrary sequence of bytes that we have understood into being something distinguishable, because a file is just a sequence of bytes. So we have a space, colon space, integer space. You know what I mean? These are just byte values. So we have to figure out what's important. So the lexer splits source code into things. Again, this is just a high level overview. I know a lot of people aren't going to need this that are here. And the parser, we talk about how it actually understands the program. So a compiler has to understand the program. It has to know what the programmer meant by this source code. Because the programmer meant a is a variable and it's of type integer. A is reassigned to 69. right? But all it has is this arbitrary sequence of bytes. So the lexer splits it up into things that sort of seem like they may be understandable based on delimiters. So you just split it into pieces. Eternal Wild Fox says, hello, how are you doing? I'm doing good. So good, Eternal Wild Fox. Eternal Wild Fox was the first in chat. How about that? How about that? How are you doing, Eternal Wild Fox? Thank you so much for tuning in. All right. So, yeah, Parser does a lot of stuff. It creates an AST, or an abstract syntax tree. You can also create a directed acyclic graph, but that's complicated. There's a lot of headaches, and I don't like to deal with graph theory in the parser. So directed acyclic graphs can be saved for later. Later optimizations, more work to do for future me, right? I'm gonna open my my one morning soda. This is gonna turn into a beer soon. Just become a raging alcoholic. Then it becomes a Manhattan, then it becomes a bottle, then it, you know, just go down the spiral. King Bun says, I was just about to say, that sounded like a Miller Lite. No, it's a mini can. It's a mini can. Not of Miller Lite, of soda. Nondescript, non-branded soda. Sorry, says, I don't like having to deal with graph theory at all. Unfortunately, there's no way around that for me now. I kind of like graph theory. I like it when all it is like edges and nodes. As soon as you get to like making sure it's acyclic, that's when it gets to like, oh god, no. Don't make me calculate. No. King Bun says, the mountain lightning, Lamau. The mountain turns white when it's cold, man. King Bun says category theory. Category theory is not bad. At least I can understand what I read in category theory. Basically, I've been on this page for a while just in case anybody wanted to read it. I'm not gonna. And we talk about what a tree is in programming. So we're beginning to understand trees. I should mention nodes here. That's probably something I should add. And then we go over an example, which is given a parsing example. So given this factorial implementation in our language, it creates this AST, right? With a little, we have comments here to specify things. And I think it's pretty clear to anybody like, okay, so factorial is an integer. It's an integer returning function, which takes in an integer. Then you get to see like, okay, there's a function here. Integer with integer, parameter types, body expressions. I think it's fairly understandable. King Bun says, is that going to go on GitHub? Yes, it is. Type checking says, this refers to the process of ensuring the types of expressions are what they're expected to be. This is only relevant due to intercept being statically typed. So because the programmer has to specify, well, it's called declare, because the programmer has to declare a type for each variable that is declared, right? So this factorial it's a function which returns an integer and takes in an integer. So that function signature is a type. And effectively, because this type has been specified by the programmer or declared, then we have to ensure that this type is basically insured. We have to ensure it's insured. No, but we have to make sure as the compiler that the programmer, the type they specified is always being taken into account. Sir Aid says, if you want to check out the current state of things, the IR branch should compile, though right now when you run it, it only prints the IR and some register allocation stuff. Yeah, I think we're going to go over high level. We're going to wait for it to be done. Then we can look at actual code implementations that are working and be like, see? Here. You know what I mean? Because right now I think we're going to build some very fundamental knowledge about intermediate representation and register allocation. And why it's even, like, it took me so long. It took me like all of yesterday to go, this doesn't even make sense. Held a message for misogyny. What's up, Femi? I love that they don't call that a curse word, they call it misogyny. Am I a woman now? Sarade says, it can be a bit confusing at first, lol. It's just, it seems so backwards. It's like, let's assume there's infinite registers, that way we can solve a really complicated problem of mapping infinite registers to 16 registers. It's very confusing to me, at, like, on a fundamental level, why it happens. But there are reasons. They're just not intuitive at all. Vimy says, in Australia, they call it a proper greeting. I'm fine with it. I was just mad at Twitch. They called me a woman. It's so funny. They'll never win with that one. It's so good to see you, Vimy, though. Amazing. One of our first donators ever. Vimy in the house. Yeah. So, code generation. If you're reading this, thanks to Sarade, our compiler has an intermediate representation. I didn't budge easy, but he was insistent and convincing. That's very true. Vimy says, are we doing white paper review now? No, I wrote this in LaTeX. We're actually just working on some documentation for the language for new developers to understand. We haven't even gotten into it yet. I use TixZ. If you're not scared of me yet, I use TixZ. So there. No, TixZ is great. It's very understandable. But thanks to Sarade, we now have an intermediate representation. And if you're like me, you wonder why. Why do we even... King Bun says, in Colorado, they call it a hate crime. Dude, is that a hate crime? I think so. We should bash him. Let's hammer him. Vimy says, please don't show me LaTeX. I get Vietnam flashbacks. It's what we're working on right now. I'm sorry. Well, we're focusing mainly on the output, on the PDF. Because I wrote most of it already. We're just going through. So code generation in our language, thanks to Sarade, has an intermediate representation. So what does this mean? So back at the beginning, when we go parsing, type checking, code generation, you can kind of imagine code generation, and maybe I should draw this as a diagram in TixZ. Code generation kind of has a front end, a middle end, and a back end all within it. So this 3-stage thing, there's another 3-stage thing all within code generation. Right? So code generation begins with an AST, a type-checked program. So this abstract syntax tree is used by the type checker, and it's iterated, and every single node in the entire program is ensured to have correct type semantics. So if there are improper type uses, or like an assignment to a function, a fact, like fact is a function, right? So if you assigned it to an integer, like just 1, then that would be a type error, and the type checker would catch that. But the AST, assuming it's correct, it doesn't need any changing by the type checker. The type checker just ensures the AST is correct. we got more held messages. I don't even know why. It gave me a message in another language. So I'm sure that means something in another language. But they gave me a message in that language as well, so yay. So this is a complete representation of the program, the AST. And if you're like me, you're wondering, if we have a minimal complete representation of the program, why do we need an intermediate representation if all it is gonna be the same thing? Like it's, oh, there's a program, it has things. It's like, if everything's the same, why do it, right? This is my initial instinct, but there are good reasons. There are none, right? Here's a list of reasons that were used to convince myself of using an IR. There are none. Seriously, we could use the same data structure, our nodes, and reorganize them and build a new tree, right? And it would have the same semantics of that intermediate representation, because the actual underlying data structure is the same. But it would overcomplicate things, because now in the parser, when we do, for example, a switch case, and this is kind of small beans, if that makes any sense. It's not a big deal. But when we do a switch case, most of the time it's on the type of the node. And the type of the node, if we take a look at that, is this enum node type. So all of the types of nodes have to be in this enum, right? Which means that when we check this type value, they're against this enum. And we assume if it's outside of this, it's usually invalid. So that means that we could have nodes with an invalid type or bugs, but they would have a correct within the maximum type, right? So we don't want to generate like an IR node in the parser, but we may on accident, and it wouldn't catch it as a bug. It'd be much harder to catch as a bug. So that's not really an option. But what we could do is create a new enum, because this is just an integer type, right? So we could create a new enum IR node type. And this is almost what I did. I was like, I think we should just do this instead. Because we could just create an enum IR node type. We're not going to, but this was my initial idea. And then you can create, IR node phi, IR node value, IR node max, right? Then when you reconstruct a new tree from the AST, you just use the new enum, right? And the type can then, from then on, be checked against these types rather than these types. This would 100% completely work. And we could even do it where like this equals node type max, so they don't overlap. Isn't that beautiful? We could use the single data structure for our intermediate representation for our abstract syntax tree, and we could probably fit the lexer tokens into here as well. I don't think tokens need to be a separate thing anymore. I think they should just be plopped into the nodes themselves. We could literally have one data structure across our entire code base for everything. The problem with that is it kind of overcomplicates things by having it too simple, right? So if we look back at the PDF, I started to think, well, why should we use the same data structure in parsing, type checking, and code generation if they're entirely different and they all do different operations? vme says the everything structure. It's true though. We could literally fit all of our data inside a node. We never need anything other than a node. We can just reorganize them in different ways and everything would work out. Right? We could have different types of node types, right? We could have types. We could go insane with the single node. But I don't think that makes it simpler. I think doing that actually overcomplicates things by making it too simple. Because you may understand the one part of it, but it may be hard to understand how it's used for both parsing, type checking, and code generation. And again, we could have issues where we're passing wrong trees because basically they're all the same type, so there could be no type checking. By separating them into different structures, we... Be me singing in chat. Going insane as we ride the time machine. With a rainbow frog. It's pretty great. But we could have everything in one single node structure. But that means type checking. Everything would just be a node. So in the IR backend or front end or wherever you want to call code gen, right? When you're generating IR, you could accidentally pass through a node and not realize it. Or you could have very broken trees and the compiler wouldn't help you at all. So to actually improve or to decrease the complexity of the program, we have to make it more complex. And the reason this was hard for me as well is because Sir Aid is he's very smart. And he knows a lot of things, even if he doesn't know that he knows a lot of things. He knows many things, right? So seeing him implement, like, oh, let's do static single assignment. Oh, let's do Chaitin-Briggs register allocation. These were both brought on also as intermediate representation. And I was like, this is way too much. This seems like way too complicated, way too fast. What's happening, right? But the fact is, Sir is just very smart, and he's taking very simple tools and doing great things with them. It's just hard for me to, it was hard for me to picture that. It's like a blacksmith telling you, like, yeah, I can, like, make my face in an iron bar in 45 minutes. And you're like, yeah, right. You're like, that'd take you so long. And then they go and do it and bring it back to you, and you're like, okay, this is a little different. You are much better. How'd you do that? And then you're wondering, like, wait, that had to be so hard to, how'd you do that? And then you start having the confusion, right? Basically, the idea with our intermediate representation is that it starts to optimize our language at the same time. So the idea is that currently, it's kind of hard to picture how this could be optimized, because, like, where are the control flows? It's not just intuitive where it happens, right? It's not like, oh, where are the branches? Where is each function body? I mean, you have to have this extra comment here just to tell you, oh, this is this, this is this. So the AST isn't intuitively representative of the overall thing. One big reason why the IR is a different data structure is because it's in SSA form, the AST is not. Yeah, we haven't gotten there yet. We're getting there now. This means that IR makes optimizations like dead code elimination much easier, and register allocation is also simpler because I don't have to build DU chains because each value is already a do chain. You're correct. That was a lot of words. What Sir means is that effectively, with our AST, we can access a variable and reassign to it any amount of times, because the AST just represents the abstract view of our programming language, and our programming language allows for these things. And these things make it very hard to optimize code, because if you have a reassigned value, then that means that this reassignment is only live, like this reassignment and this value to this variable is only valid for until it gets reassigned again, which is kind of annoying in optimization, and you have to keep track of all these ranges within the program, and then as soon as loops and control flow and recursion comes into play, it's like, whoa, that just got complicated, right? So this is almost impossible to optimize, right? It's definitely doable through peephole optimizations, as I talked about before, and that's my instinct. My instinct is to say, well, let's just use the AST, but in the backend, we know that on x86-64, there's this certain optimization we can do. So when we see a binary operator with a plus, and there's two, and there's like a value on one side, then use that as the source and store it into the other side, and etc., right? We can save a register allocation through a peephole optimization just by seeing this little case here or this little case here. But that doesn't let us do overall program optimization where this entire function body can get inlined into a function call, right? That's almost impossible, because from this function call, how could we ever tell just by this little function call peephole that there's any optimizations to be done? It's just a function call, right? So you can do many optimizations through peephole optimizations, which is my instinct. I'm not sure why. I don't think it's correct. It's just my instinct. And it makes things harder. Also, these aren't lined up, and that bothers me. Why? Why? Why have I done such things? 26. Perfect. That's better. Okay, just do a quick recompile. Plop those over. Yep, anytime, Emacs. There you go. Perfect. So with this data structure, it's kind of hard to intuitively tell what's happening on a very high level in the program, and that's much needed for optimizations to happen. So while it is a complete representation of the program, it is not an ideal representation of the program, right? So the compiler can use it to type check. I think that's totally valid, because all of the information, type checking information, can all be peepholed, right? Everything is like, oh, a binary operator less than on n and 2. You can check that both of these are integers and then go, okay, this is valid. And then you can look at just the if and say, okay, is just this if valid? Is just this function valid? Is just this variable, right? And you can go bottom up through the whole tree. And it makes a lot of sense to do it that way, at least in my mind. And eventually we could switch to continuations over recursion, just like in the parser, and it would be very efficient. So, with the type checker supposedly using the proper data type, maybe there's something else that we can use other than a tree in the future, but we'll see, like a directed acyclic graph. Not important. Sarade says, yeah, type checking is usually done on the AST in my experience. Big Daddy Sarade comes in with the quickness, with the answer. That gets me excited. No, but he's right. Most compilers use a tree data type to do type checking because it's exactly like I said, it's just easy to do peephole type checking. There's not really cross type checking that you have to do in these types of languages. However, with code generation, there's some problems, right? So the problem is like, to generate code for an if, imagine all the different possible platforms that we could generate like an if branch for. We're gonna need WASM. I don't know what the syntax for branching in WASM is. Do we just have to like make another function with this body and then call it? Like, I have no clue. So in order for this to kind of be a higher level thing that can be reasoned about without having to worry about this type of backend problems, what we do is we assume there's no backend. Isn't that convenient? Chat. Isn't that convenient? No, it's just like, oh yeah, what if there wasn't any code generation and the IR was our final program? And since the IR doesn't have to run on any hardware, well, guess what? There's no hardware limitations. You can have infinite memory. You can have any amount of temporary registers that you would like. We only have 16 64-bit registers on x86-64. If it's in WASM, is basically like if in Lisp. Oh, that's beautiful then. That's going to be easy. Anyway, I love Lisp. Anyway, our AST almost directly translates to Lisp, if you don't know. That'd be a fun time. What was I talking about? Oh yeah. So basically, if there are no hardware limitations, every value could just be stored in a new register. Can I zoom in? Oh, I cannot zoom in. Emacs is mad. I have to... Ooh. That's not bad. It's a little blurry for me, but it looks okay. It's very blurry. Basically, hardware limitations, if there are none, every value could just be stored in a new register. Why wouldn't there be infinite, right? Why can't we just use a new register? There's no hardware limitation, so just use a new one. With this, we would never have to worry about slowdowns from RAM access. So, for example, parameters, or arguments, I should say, passed during a function call, we pass them on the stack. That's slow. We have to do memory accesses every time we access that variable, or write to it, or anything. And the RAM is much slower than the CPU, by a lot. So it's like you have to take a bus and go get memory, and then the bus has to come back, and then the memory has to get off the bus, and then the CPU can finally get the memory and read it and go, okay, this is a value in a register. It sucks. If everything's in registers, it's just CPU internals. So it's already close to each other. It's made to do it with the ALU and everything. It's beautiful. So what would be ideal is if everything was just in a register and there were no RAM accesses, right? So let's have there's no hardware limitations. Infinite registers means we don't need RAM accesses. We can just pass everything in a new register. And the word register here is starting to become misused because it's no longer referring to a hardware CPU register. So if you would like, you could start thinking when we read register here, you could presume that it just means variable. It really doesn't matter. So this register could also just be a variable. So imagine if you never had to do any memory accesses, then you can always just move registers to registers. So basically, register A equals register B. Register A equals register B plus register C, right? Stuff like that. Isn't that beautiful? Sir 8 says, once the register allocator is done, it'll be trivial to use the platform calling convention for internal calls too. That's beautiful, which means, Sir 8 didn't say it, but that means that we would have C interoperability. So you could both, whoops, it went off the top. You could have both, currently what we have, which is external functions defined in our language, which is currently called intercept in this paper. In the tech file, I literally have a thing at the top with the language name. We could change it to anything. So it is not set in stone. There's literally just, you change it in one place and it changes everywhere. So just so you know, it's called intercept. That's the name of the language here. That's just because it was my first idea and it's probably not final. It almost certainly isn't final. It will be final if we ever rename the GitHub repo. That's when it's final. It's like, ooh, we did it. Until then, it's up in the air, baby. It's like a graduation hat. Anyway, everything could be in registers, and only when the user explicitly dereferences something, right, would we begin to have memory accesses generated. Imagine that. It's like a code optimizer's wet dream. Everything in a register and only explicit memory accesses. Doesn't that just sound beautiful? It's like, oh. And that's when I started to understand the intermediate representation. It's like, what if our program could be perfect, right? What if there was no hardware limitations? What if we didn't have to live in this stupid world? Then we could just have computers that worked like this and it'd be easy. RPWH, yeehaw! One of our longtime contributors. How's it going, RPWH? Or at least multiple time contributors. Unlike most of our contributors. Shout out RPWH. What's good? What's good? Trade says, oh yeah, I already read that. I'm good at rereading things. Yeah. So, like me, you may be thinking there aren't infinite registers in hardware implementations, right? It's fun and all to think, oh, what if life could be perfect? But it isn't perfect, and it's very harsh, and there's only 16. There's 16 64-bit registers in x86 64. Even in 64-bit. That's not right. Even in x86 64. There's only 16 64-bit registers. What did I... Oh, the underscore. Just thinking it's in math mode, so we have to backslash escape. I can't speak. We have to backslash escape the underscore, otherwise it thinks we're trying to do a subscript. RPWH says, I'm good, learning a bit of Go for work. Sir Aid says, ah yeah, classic LaTeX, it's true. Any underscores? Big bad. Unless you're in a verbatim. RPWH, that's awesome. Or it could not be awesome. It depends on what you're doing for work, I guess. But it sounds fun. I like learning new things. It makes me upset, but it makes me smarter in the long run. Just a little warning. This is very over-the-top warning, but it is pertinent. The following section contains, like, vocabulary regarding topics of life and death. We're just talking about silly computer programs, so we're not meaning to bring up any offensive terms or memories or anything like that. So if you're sensitive to topics like life and death and talking about morality, we're going to be talking about the lives and how long variables are alive for. So, and they're going to be dying at some point in the program. This is not ideal terminology, but there's almost no... You can't Google any other terms and have the proper content come up, so we are going to use these terms, otherwise people won't be able to learn more about it on their own. So I do just want to mention, that is a thing. I know it seems a little like over the top, but it's true. Imagine something happened for somebody, we don't want to just have them have a terrible time just because we're talking about code optimization, right? Sarade says, typically we call them live, not alive. Like a wire, basically. Right. Live or dead. Or alive or dead. I don't think there's a difference. I could say live. It is called a live range. It's weird to me to call something just live and not alive, though. I would also call a wire alive, but that's probably just from where I'm at. I've worked with electricians. They definitely go, the wire's alive. Or they say, those wires are live if they're talking in plural. It's probably just where I live, though. Singular versus plural is almost always things. But yeah, we are... Negvorso put in two crying faces. Hopefully it's not too offensive for you. But we are just talking about variables and whether they are in use or not in use. We're just going to be using these terms because these are the terms that are used. And ideally, in an ideal world, we would not use these terms. And we're going to move towards that if we can, once we are understood and everything, if we figure out a better alternative, is what I'm saying. So effectively, consider... There's basically a variable is considered alive after it has been assigned, but before it has been used. That's only in static single assignment. That's technically incorrect. But we'll go with it for now. Live range says the range of expressions in a basic block in which a variable is alive. We definitely have to rewrite this part. So let's just start, right? So let's take in Sir Aid and go live. A variable is considered live, not alive. I like it. Or live is live. Live. Okay. Okie dokie. So we are now live and not alive. They're live ranges. So that makes a lot of sense. Whoops. Did not mean to change the size. That's what I get for using the mouse in Emacs. So effectively, we would like to talk about basic blocks. And I think the best way to do that is with this diagram. So this program that we are looking at here, you can see we make integers a through f. So a, b, c, d, e, and f we declare as variables, and they are all integers. There are two input conditions. Imagine that these change or are different, like function parameters or something like that. Or they could be externally linked symbols. I don't know. Something. Effectively, just imagine that these are changing. They could be anything. And these numbers on the right after the comments are just to simply keep track of which expression is which, because on the next page, we can see the generated AST. So you can see 0 and 1, the input condition and if condition, they're both there. So you can map where they end up in the AST. So 8 and 9, you can see 8 is the while, 9 is the condition, then 10 is the first. See, it's here. So it lets you keep track of all these expressions from source code into AST into a basic block structure. This is where it gets fun, right? So effectively, up in the code, you can see that we have if input condition, and then f is assigned to 2 times e, and then else b is assigned to d plus e, and e is assigned to e minus 1, right? So this is a branch, right? So the idea is that this branch is, it can either go to the then, where f is assigned to 2 times e, or it can go to the else, where b is assigned to d plus e and e is assigned to e minus 1. So you can see 15, 16, and 17. So 15, this here, ends up here. Does that make sense? So the if can either go this way or this way. Both of these then fall through to this basic block here of code, where b is assigned to f plus c. Right? So no matter which branch we take of the if, we end up at the same position. Sorry, it says looks about right. Yeah. Awesome. So with that, that's the end of the while loop. So we will go back up to the top and continue and forever be in this loop, right? So the idea is that here's what happens at the beginning. Here's the first block of the while loop. with 10, 11, and 12, expressions 10, 11, and 12. So that's these three expressions here. Let's put those on a new line, while one, just so that they're a little more separated. And you can see that they end up here, 10, 11, and 12, which are all assignments. And this AST has a little bit of a different syntax for what we're going to end up with. We're going to make some small changes, like change from reassignment to just assignment. And then we're going to change from having declarations store a child symbol into just storing the symbol as a value. But that's there. Negvorsa says using uninitialized f. Yeah, that's on purpose. Eternal Wild Fox says, yeah, victory, check Discord. We're going to do it. We'll check out his victory. What'd we get? Finally some progress generating a Visual Studio C# project file from my BuildMake program, which I can open. Oh, that's Pog. If you don't know, Eternal Wild Fox has been working on a, oh god, it's further up than I thought. Eternal Wild Fox has been working on a project called BuildMake, which is much like CMake or Premake, and it's going to be a build system generator. And you can see that he has generated a Visual Studio solution up here for VS 2022. And he can actually open it, and it's a default C# solution. How beautiful is that? How beautiful is that? A cool little build system generator. You are getting there. That's a lot of progress. Very awesome, Eternal Wild Fox. Thank you for sharing that. That is so cool. That is very cool. So effectively, the idea is that with this basic block structure, we can determine the control flow of the program at a glance. It's very easy. Eternal Wild Fox says, no problem. Awesome, thank you so much. So effectively, this lets us see, okay, this block of code gets run, this set of expressions. And this is a mathematical set where it can also be each item can also be a set within itself and can have more basic blocks created, which can get confusing, but it just alters the diagram. Saraid says, I like the diagram, also be right back. Lander XT says, Lander? Missing a Lenser stream? What's good, Lander? It's so good to see you. Yeah, Eternal Wild Fox was our first chatter today. It wasn't Lander. What is going on in this world? Also, I missed some chats from RPWH. So sorry. He says, I'm excited. Nice to do something that isn't Python or Java. That is a good point. That's almost all people want nowadays. Lender XT says, I just try to show up every time now, not first. You're doing amazing. I appreciate it so much. I can't believe there's actually a person that shows up to all of these. I didn't think anybody would. So with this little diagram, we can see that this is the control flow of the program, and that these basic blocks get created for each effectively block of code that can be run, right? And in doing so, we can start to begin figuring out what variables are in use and where, right? So what we can do is say, okay, E is assigned to here. So let's say it becomes live, right? So E is now live after 12 or before 13, right? In between here, E is now live. So with E being live, you can see that it'll be live all the way up until the last time it is used in one of these paths. So you can see that E is live here in this basic block because it is used. Is this starting to make sense? So E has a live range of at least here to here. Is this beginning to make sense? And if you can imagine, if we arranged these basic blocks in a flat list or an easier to understand structure, then we could have indices which describe a live range. Or we could arrange these basic blocks as they are as a tree, And then we could have pointers as our live ranges and say E is alive from here to here. But here's the thing. LanderXT says, you saying we're insane? Yes. LanderXT, you are insane. That's what I'm saying. No, you're not. I'm just saying it's baffling to me. I don't know if I would watch every time I streamed. You know what I mean? Which is sad, but it's true. I'd probably watch this one. So in this basic block, we can see E is used twice. So E is also live after expression 16 and after expression 17. Right? So at the end of this basic block, E is live, and it's also like made live again because it's assigned to, right? So E is live here because it's used, and E is live here because it's used, and E becomes alive here in this basic block. So you could say that in this basic block, E is not live. It is not used in an expression. However, in this basic block, E is live because it now has a value and it has not been used yet, right? The furthest extent of its use has not been reached in the program, so it is still alive. So E would be alive here. If we go down this, we can see E would still be alive, and if we go down this, we can see E would still be alive. So what happens is when we get here, well, E isn't used anymore, right? So effectively, E would become, it would either still be alive and continue over, or it would just not be alive because it is not used in this basic block. The reason I'm saying or is because I don't know. This part is not described by anybody. It's called liveness analysis, and it's very complicated. Effectively, what we want to say is E becomes live here in this transition from the first basic block to the if basic block, and it dies or becomes not live in this at the beginning of this basic block, before this basic block. If that kind of makes sense. Also, a classic me not turning off my phone notifications. Okie doke. So, why is this important? Why do we want to detect when E is live and when E is not live? Why would this help us at all? Right? It's kind of confusing. Why? And the reason is because once we know this, for example, if a variable is live throughout an entire program, then you know that in all of the program, you cannot optimize this out. And in fact, you're going to need to save it. So might as well store it in a register. RPWH says, did someone say lifetime annotations? No. Lifetime annotations are bad. Should all be automatic. But we do have to figure out the lifetimes of variables, how long they are live for. And what we start to piece together is we'd have to calculate lifetimes for each value of E that gets assigned to. Because E being E minus 1, it doesn't matter if E is still alive down here and we use it. If we took this other control flow, we can't use the result of this variable or this expression. We can't use this register when we access E because E may have been assigned to up here. Does that make sense? So this value would change when we use it later depending on which control flow we take, which means we don't know how to optimize it correctly. And that's difficult. LanderXT says, anyone got a spare credit card? Lamel. Negvorsa says, without thinking of the notion of scope, it's hard to reason. Right, so imagine this is all in program scope. That's why we're doing top level. We're just in the program. So this is like the main function, right? This is just global. Everything here is global. And with everything being global, you can imagine that it doesn't make sense that like E being accessed in all these different ways, if it's accessed after this loop happens, well then that means E could either have this value or could have this value, so it's going to be difficult. What we did before was use the same register or the same memory and then just read from the memory whatever is in that place. But this doesn't work really if we want to have an IR with everything in a register. If we want to start optimizing and using registers, well, which register do we use? The result of this expression or the result of this expression? It's kind of confusing, right? So the fact that these are in multiple registers all of a sudden kind of breaks down it being a single variable. And when you start to think about that, it may not be the worst thing. A variable has different values at different times throughout the program, all with different lifetimes. They almost sound like different variables. And what if they were? And that is the idea behind static single assignment form, or SSA. SSA form is a form of program in which each variable does not get assigned more than one time. How does that work? Does that mean that we have to disallow reassigning to E here because we've already assigned to it? No. We let the programmer do things like this, and then in the intermediate representation, we just create new variables. So all of a sudden, instead of E being the same here and E being the same here, and if E goes on to be used, again, it's not, so this wouldn't happen, it's a bad example, but if E was to go on to be used, then that means that we could either have E, which is this E, we'll call that E1. Like imagine there's a little subscript 1, right? And then we could have E2. So this is E1, and you can see that we use E1 right here to calculate E2. And we use E1 right here to calculate F. So all of a sudden we can clearly see a dependency start to form where F depends on E1, E2 depends on E1, right? This is starting to make sense. But F does not depend on E2 because it doesn't at all. It's completely different. Every time we reach F, E will be assigned to E1, and then F will use E1. It'll never use E2 in this calculation, given this control flow. Isn't that beautiful how we could just determine that just by simply thinking about E, both assignments of it as to, also I just said both, kill me, both assignments of it create a new variable. This is E1, this is E2. And the same thing could be said for B. B could be B1 here, and B2 here. And then you can start to go, okay, so A may depend on B2, but A may never depend on B1. And with this dependency graph, we can start to piece together which values need to exist at the same time, which means we need at least that many, right? We need at least that many registers or temporaries to be able to store these variables or these values. Is this starting to make any sense? So effectively, by moving to static single assignment, we start to go, okay, when we calculate F, we need E1. So by moving E1 in the CodeGen backend, if we moved that into a specific register, racks, then when we take this control flow, all we have to do is move racks, is really just multiply by 2. That's all we'd have to do, because E is already in racks. Do you see how that works? That's an optimization, but we'd effectively just multiply racks by 2 and store that in F. So these 3 values at least need their own register. Or, again, peephole optimization, convert the literal integer into a literal in the assembly, and we could multiply by 2 literally. But assuming these no peephole optimizations, this would mean that 2 gets moved into a register. E is already in E1, it's in some register that we've allocated. and we just multiply that to get F. So we need 3 registers for this. Technically 2 with peephole optimizations because of how the specifics of how x86-64 works. But overall, there needs to be 3 temporaries, 2, E, and F. So Aid says, I'm back, what did I miss? Liveness analysis and SSA. We basically talked about how separating E1 and E2, so each assignment of the value, each of the, Negvorsa says a lot, it's true. Soraid says, I see. But yeah, we had E1 and E2, and how if E were to be used, then that would mean that E2 would be used. And E1 is used to calculate E2, so E2 depends on E1, E1 depends on D, and then with these dependency graphs, we can start to understand, okay, if F depends on 2 and E1, right, E1 up here, then E1, whatever register we allocate to it, we can just use that down here in this basic block. So you can see that E1, F, and 2, the literal 2, all need to coexist at one time, which means that we cannot put them in the same register. So what we do is say, okay, we need at least 3 registers, or so to speak, for this equation, for this basic block. So then register allocation, you know you need 3 registers. And you know you need one of them that was used up here. And you can start to go, okay, well, if we use this register up here, what registers can we put A, D, and E in? Well, with that, you have to know how long they live, because A, it's used in D, or it's used to calculate D. And then A is never used again, if you'll notice. So if we made this A1 into static single assignment form, this is our one assignment of this A variable, A1, then that would mean that A1 is used here and never again. And with static single assignment, there's basically the last use means that's when it dies after this expression. So after expression 11, A is dead. A is no longer needed, which means that the register allocated to A can now be used again for E. So A and E can be stored in the same register. Isn't that cool how we just figured that out? We're doing it by hand, but this is called Chaitin-Briggs, or Chaitin-Briggs, I don't know how to say it, graph coloring. And I don't know exactly how to explain it in the proper words, so let's ask Wikipedia. Also, you can't see what I'm typing. Lol. Anyways, if we look at Chaitin's algorithm, it's a register allocation algorithm, and I couldn't really understand this. It's a little confusing. I still don't understand it totally. I understand what spilling is, but the fact of like coalesce and build being it's a little confusing. However, this is the basics. Basically, you only have a number of registers based on your architecture. Soraid says, I have yet to find a good explanation of Chaitin-Briggs online. Hopefully, I'll be able to provide that, because all I need to do is start to understand it. Soraid says, I have a book that explains it pretty well, luckily. I'm pretty sure I'm going to create like the first YouTube video on Chaitin-Briggs register allocation that actually makes any sense and doesn't just pop into existence. Of like, here are the answers that I took from this book. Anyway, see ya. RPWH says, how do you let the compiler know you want a variable to follow a different lifetime rule, Kappa? If you can give me a real-world example where that would be necessary, cool. Then we would add some syntax for it with a lifetime annotation. But there would never need to be one. Just let me know when there would need to be one. Because we're not doing borrow checking. We're not doing complicated stuff like that, really. We're doing type checking. It's not really important. And as far as the IR is concerned, all the types are already set in stone, so everything's good. Okay. Let's try and write down some of what we just said. Each assignment of a variable after the first creating new variable is the entire idea behind SSA. Let's take a look at the example above, converted into SSA form, I guess. Again, how do liveness analysis? Still confused on that. We'll get there. We're going to steal this little blop here. And we're just going to change some things. So we look at our PDF. Sir Aid says, I'm probably going to add a section on register allocation to this once it's done. That would be beautiful. Nexovec says, hello Lens, how's life? It's life. The stream is going better than life. How's it going, Nexovec? Thank you so much for tuning in. But yeah, I would love to have a section on this. I write very oddly in LaTeX. I will warn you. People get scared. Okay, but effectively, we want to say that E here creates E1, A here creates A1. So let's go through and find A. So I think if we do something like this, that will become subscript. See, even Emacs is making it subscript. How pog is that? And then we can just start to do some things like this. Right? So this is F1. I don't know, we're just going to call this F for now. I don't know what that actually is. You can see that this is A1. And at this point, A actually dies. First time chat from a viewer, Tizek. I wish I knew anything that was going on, maybe one day. RPWH says, join the club. Basically, we're writing a PDF to help me understand intermediate representations in compilers and how to do complicated things like register allocation and basic block optimizations. Effectively, overview. Language has 3 stages: parsing, type checking, code generation. Parser converts source code into a data structure that represents the program in its entirety. So the entire program, there's a lot on how the parser works. We talked about it earlier. This program, which is a factorial implementation in our language, which we're calling intercept for now, this program can be represented entirely by this data structure. And it is represented entirely by this data structure in our language. So it says, I'm fine so long as you don't do something like /begin text it /end text it, or use /subsection just to make text bold. Oh god, no. You might find that absurd, but once I had to deal with someone else doing that all over the place in a 400-page book. Oh no! How? How did they screw up that bad? Nexovec says, I probably can't even do what you're doing in LaTeX. Lamau, Nexovec says, no compile time execution and intercepting the compiler? We're definitely still going to do that. We're going to have a compile time evaluator. Don't you wait. Don't you wait. RPWH says, what happened to lens script? Well, nothing happened. In fact, the language name is defined right here. Just for you, RPWH. It's now called lens script. How about that? We probably have to change the verbatim ones. But actually in text, it's now all changed. Currently, lens script has 3 stages. Parser converts lens script, source code. See, it's just in the verbatim code examples. RPWH says, pog bones. Yeah, lens script. But it's just a placeholder name. I just had to call it something. So the parser converts this source code into this program. You can see there's a declaration of a variable called fact, which is a function. It's reassigned to a function, a lambda, right, with a body. Oh, excuse me. And you can see that there's a branch. If n is less than 2, then integer 1, else binary operator multiply of n multiplied by the function call of fact of n minus 1, which is exactly this right here. And then you can see that is the end of the function body. So whatever this if expression returns, that is the result of the function, and it's an integer, so it works out in both cases. And then we call to this function, and you can see that that's after the reassignment. Next of x says funpiler, lamau. But yeah, so you can see with this function call, also I'll get rid of that ugly thing on the side, my bad. So this is a complete representation of the program. The type checker will take this tree, and it'll go, okay, are the types correct? And it'll start at the very bottom and go, okay, for the variable access n, is that correct? Is n a variable? Okay, integer. Okay, integer's an integer. Cool. Binary operator. Is n an integer? Is integer an integer? Yes. Okay, binary operator returns an integer. Is the argument to factorial actually an integer? And we'll start to slowly make our way up in this sort of fashion till we get to the whole program. Look at that. Sir Aid says constant folding / a simple tree evaluator is probably one of the first optimizations that I want to implement. It'd be fun to watch the compiler optimize away a program to just move value racks. An entire program. True. So I think we should... We're gonna want to have some way of enabling and disabling optimizations. And I think I want to include compile time evaluation in that. But yeah, that's a good idea. So like, instead of, I mean, there's no compile time evaluation that can be done here. It's written on purpose like that, but Sir Aid says, yeah, for sure. But yeah, we're going to have to implement optimization passes. That's going to be so much fun. And I think it's going to be easy once we have all the functions and basic blocks. Like in the IR, I see why optimization is done this way. It's going to be not easy, but it's going to be very doable. Sir Aid says, otherwise debugging anything would be horrible, lol. Yeah, it wouldn't be easy. Wouldn't be easy. Effectively, once we type check everything and kind of go through our whole thing, everything is perfect. And then we go, okay, now it's time to generate code. We want to actually make some sort of executable in the end, so we need to have some way to do that. And before, what we would do is go straight from the AST into the code, but Sir Aid, thanks to his insistent and convincing arguments, we're going to have an intermediate representation, and it is absolutely the right way to go. It's just non-intuitive in many ways. The ideal part of it is intermediate representation does not conform to any hardware, so you can just have infinite registers. You never have to store things in memory unless the programmer does that explicitly with pointers or things like that. So how beautiful is that? Each variable could have its own register. And in fact, you don't even have to call it registers anymore. You can just call them variables, right? And the idea is that once you know that these variables can each be stored in their own register, kind of becomes complicated to actually map the infinite amount of registers in the intermediate representation into only 16 for x86-64. And to do that, here's our little new graph we're beginning. You say each variable, every time it's assigned a value, that actually just creates a new variable. So if we were to assign a to b plus c, use it here, and then say a is assigned to c plus d, we would have a1 be created here and a2 be created later. For example, e. Let's take a look at that. Currently, it's just e. It's assigned here, and we're just going to add a subscript 1 to e here, subscript 1 to e here, because they all refer to the same value of e. And the reason this is important during optimization is because this is a different value. And because each value, please, is stored in its own register, what this means is that we know that anytime we access E1, well, we'd have a register storing E1. It's already been calculated up here, and it's in use. So this register is all the way in use to the furthest use of E1. But after E2 gets assigned, we can't just assign the register to E. Because if we did, then that would be a different value, and effectively we would alter E1 being able to be used here in F, even though it's a different control flow, which is not what we want, right? So if we look at that in the PDF, it may make more sense. So you can see that E1 is used here and here and here. So they're used in different branches of control flow. However, if we were to later on use E, the variable, would we use the register E1 of D1 plus F, or would we use the register E2 of E1 minus 1? Right? Which one do we use? It's almost impossible to know. Unless we have this E1, E2. So if it was just E, there's no way to know. But with this 1 and 2, we can now say, well, after this point, E2 is what should be used. After this point, E1 is what should be used. And that's exactly what happens. How beautiful is that? So each variable kind of gets its own value and its own register and its own variable almost, right? So the fact that B is assigned here, right? This should probably be B2, but we're going to call it B1 for now. You can see that we use D here, and if we go up the tree, then we can see that D1 is the most recent assigned value of D. So with D1 here, then you can see that, where are we at? Yeah. B1 here, then this converts into B2, right? This still going to be F1, and so we should probably make F initialized, but it doesn't matter. As you can see, what this ends up with in our final program, in our final diagram, I should say. Plop. We should probably also deal with F, but it's fine. So you can see that if we store A in a register, then we know that anytime we access A1, we can just use that register directly. We don't have to think about, like, does it have the value, does it not? Because in our intermediate representation, we have infinite registers. So each of these computations just goes in a new register, and it's that easy. The problem only comes when converting into hardware, when there aren't infinite registers. And this is where register allocation comes into play, right? So with register, also, I know I'm going over what I just went over, but it's also just to get it down in my head, because it's a complicated issue. So effectively, to allocate registers, we have to start doing liveness analysis, which is to take these variables and figure out how long they are live for. Also, that's totally a wrong definition. Let's change that. Live is considered live after it has been assigned and up until the last use of this variable. Okay. And then a live range is just the range of expressions in a basic block in which a variable is live. That's still correct. So you can see, for example, if we just look at the source code, if we take a look within our while loop, where we were looking in the other cases, we can see that, okay, A is assigned to here for the first time, and then it's used here, and then is A ever used again? It is not, right? So this means that after this expression 11, A is no longer live. It is dead. It's dead air, dead wire, right? Sir Aid says, yeah, that's correct. A. Big Daddy himself. So with A no longer being live after expression 11, that means as soon as expression 12 starts, Sir 8 says, do you explain basic blocks anywhere, or did I just miss that? It's not actually in text, but I did explain it. You were gone. We talked about each of these diagram blocks in the diagram represents what's called a basic block. And we're in the global scope of the main function. I didn't talk about it explicitly, but I did point out that these are each called a basic block, and each of these can be expected to run concurrently or atomically or whatever you want to call that. And effectively, each basic block can be have p-pole optimizations done on each piece of it, and it's cool. We talked about how we could flatten them into a list, or we could keep them in a tree structure. But it's true that this is in the wrong order currently. We have like liveness stuff, followed by not liveness stuff, followed by SSA, and then back into liveness here. So this liveness definitions up above, these should just go down below. But you're correct. It's in the wrong order. To do. This doesn't make any sense anymore. Woo! Also, that's gonna break if it's a new paragraph. There we go. So there's the AST. We have in the kill ring, we have our definitions. Where should these go? So we have our basic blocks here. We want to describe like basic blocks here. And then after that, we can start to piece together liveness. Okay. Above diagram. To do. Add diagram reference or site or something. Eternal Wild Fox says, check Discord lens. That is how I define project and evaluate it. Ooh, I'm curious. Oh, it's XML. Nice. XAML. Got some XAML. I use XML and XML schema. Ooh. So, using XML to define projects and XML schema to validate the XML. So there's a workspace, which has projects within it. The workspace schema, so this is the definition of workspace. Element. Okay, makes sense. Here's an XML schema for C#. Nice, so these are basically parsing rules in XAML. Then in C#. Very cool. XML vomit. Lamau. Sorry, my work operates in XML. I just opinionated about it with encoding. Yeah, it's not the best. That's why this is here. That's very cool. This is actually amazing. So then in C# you can define a new... Oh, nice. That's your actual project that loads the XML using XML schema. And that converts into... Nice. Very cool. Build make.xaml. Oh, this is cool. And then it validates it. That's actually really cool. So would the user write this? Because this is actually pretty simple. It's not... Because I think what we could do is write like a little program that simplifies this a large amount, where you could have like project build make net 6.0. Like I would write a Lisp. This looks like it should be a Lisp to me, right? Convert each one of these with a parenthesis and then just have a certain syntax. And that would actually be beautiful. You could define projects in Lisp and then convert that into XML and then read that here. Because it would basically just be pattern recognition. VS Code has XML code compilation. Ooh, that's crazy. So it is pretty easy. That is, if it's built in. I don't write in XML. I've written HTML, but XML is a little over my head. People, if you're working with XML, usually you're doing like actual work, and that's not something I do. No, I'm just messing around. I don't know if this is needed. So this is just to describe like what we're talking about with before 11. To do. This probably should go somewhere, but not right here. It's a diagram explaining what we mean when talking about between expressions rather than actual expressions themselves. Basically, this diagram was just here to say, okay, we have expression 10, so when we're saying before 10, we're talking about this line right here, and if we're talking about before 11, then it's in between 10 and 11, this line right here. I don't think that's needed. I think most people will understand that before 11 is not before 10. Probably should go somewhere though, just not right here. To do liveness analysis, how is it done? That's a good question. In any case, that should probably go down here. But yeah, with SSA form, then we can start to do liveness analysis. So I think SSA form would be more important. Yeah, or within some specific block of code. However, there is one more step, one more conversion step, one more step to do before we may begin. Figuring out lifetimes. SSA. And then that'll transition into, whee! Second of all, a variable is different. That's kind of confusing. We're just going to say a variable, and we should probably make this a section, SSA or whatever. So where are we at top level? We're in the code generation chapter. Or section, I guess. What chapter are we in? I thought these were chapters. Did I? Oh well. Also, that's not a subsection. See, we have chapter parsing, and then lexer parser, and we just have section type checking. That should not be that. Looks like I was in the middle of a change and I forgot. Type checking probably should be a chapter. I know it's small. It's a small chapter right now. Doesn't matter. Chapter codegen. I think this makes sense. Because this is a lot of stuff, and we're definitely going to want different sections. So what do we get into first? Eternal Wildfox says, be right back. Need coffee. Saraid says, SSA form and its implications is probably what I'd put first. Maybe you're just used to article, not report. I'm definitely used to article. It's just that I figured chapters are a good thing for a big developer's manual with 3 distinct separate stages. At least an article doesn't have chapters. Yeah, article disallows chapters. It's odd. Kind of makes sense, but effectively, so let's start with SSA. So let's begin with what? We arrive at code generation. So we have like an intro into code generation here. So this could probably move to the register allocation bit or liveness analysis or something. And so this is like end intro. That's just a comment for me right now. Here's the while loop body from our current program in terms of intercepts, intermediate representation, or IR. So this is when we convert it into basic blocks. So then after we do this, we'll say, hey, wait, there's something missing. Okay, that's good. However, this diagram does not actually conform to Lang's intermediate representation. There is one more step to complete before it matches 1-to-1. Sure. Sir Aid says, I only ever really use article and book. Nice. I only ever use article like 99% of the time. And when I don't use article, I use report. But to be fair, I'm not a book writer. I don't write big things. There's one more step to complete before it matches 1-to-1. Conversion into static single assignment form, or SSA form, for short. How about that? How about it? Okay, so yes, that's variable liveness and stuff. Or this diagram does not actually conform to length intermediate representation. There's more steps to complete before it matches 1-to-1. Conversion into SSA form. So then where's our little SSA blurb? Here and here. Perfect. Okay, SSA blurb. And this can probably actually all go within. Here, I'll do I just typed SSA. I'm dumb. Ooh, yeah, snippet has not been loaded. Section. And this is going to be static single assignment form. This is going to be in CodeGen. Yeah, we'll just do CodeGen SSA. There we go. And then we're going to need a section here, and this is going to be like liveness, variable liveness. Is this, I don't know how to title this. CodeGen liveness. I don't know. I have no idea what to call it. To do. There has to be a better title than this. Okay. Let's take a look at the PDF. We just did a lot of refactoring. Ooh, there we go. We grew in a page. Sirhaid says, I love how some people call it single static assignment and others call it static single assignment. It's like C# keywords, I know. It's like, which order do they go in? Okay. So I think the intro is now incorrect. Because we kind of bring up something that doesn't even matter anymore. Like this whole thing. Yeah. This no longer makes sense. That's true. And we begin just showing an example, some example code, and then we say, previously this would be used for code generation. However, here's an IR representation. However, that's actually incorrect. There's this thing called SSA, and it kind of complicates things. However, register allocation. Nope, however, variable liveness. That's right. And then it's going to be, however, register allocation. Yeah, to do. So this is going to be like register allocation. Sorry, it says, personally, I've only ever used the former, static single assignment. That's just how I read it the first time, so that's now what it is in my brain forever. Hey, it worked. Okay, what do we get now? So now we still get the same... This is bothering me how it's not in a mini page. Nope. CodeGen, please. Okay, what needs to be in a mini page? This needs to be in a mini page. I need to really just make this a macro, a new command. That's actually a good idea. Let's do that now. Also, it's bothering me that that's down there. We're going to do a new command for, what's it going to be called? This is going to be called code. That's not a thing already, is it? It's not. I usually just do /clear page. Oh no. No. Okay, we're going to call it /code. And it's basically just going to say, how do we do this? Does anybody know how Sir Aid says it is? I think there's a code environment. Is there really? Okay, what do we call this then? We'll call it like code with all caps. How about that? If you have a better idea, let me know. Latex command parameter. How do we use... Nope. I don't know. Sadat, what is that? I know it has, it's so simple. I just can never remember how to do it. Please let me know. Pass in an argument now. That's right, it's just an option in #1. Okay. Reference the parameter with /1. Yeah, that's what I thought. It's just the one in between. That's what I that's what I forgot. So we're gonna need begin mini page text width. So just a full page, and begin a verbatim from fancy verbatim, and then put #1 here. Would I do this? Do I do /1? I think it's /1, based on what Sir Aid is telling me. Okay, now go to the very bottom, wherever we were. We were at, no, we were at the very bottom. We were at code gen. Sir Aid says #1. Okay, I was right. And it's in like this, correct? In that? I don't know. We'll try it out. So instead of doing this, we would just like to say begin code or something. Right? So get rid of that. Code. This is gonna break. Yep. Okay. Missing number treated as 0. Perfect. Why? It says /protect. Intermediate representation example. It's right here. Am I doing this wrong? I think I am doing this wrong. I'm supposed to do this. Look at me. I'm forgetting how I wrote it. I'm like, wait, I just made a new command. I didn't make an environment. What the hell's wrong with me? Please? No? Missing number treated to 0 still? Line 301 now. Alrighty. That one confuses me. Yeah. Wait, are you trying to define an environment? In that case, you have to use new environment. See? That's where I just wrote it the wrong way. I did /begin code, but I meant to do /code with an argument. Because this is, I think, ideal. We just say /code. And it's like, oh yeah, that's code in this place. But it is not working. Rip me, I guess. I should just use mini page and verbatim. Like a little cuck. Is this the wrong part? That may have been... I'd probably make this an environment, honestly. We can. Also, verbatim is special. This is fancy verbatim. This isn't verbatim. Trying to wrap it never goes well. But it's fancy verbatim. It's from a package, man. No, we're just not going to waste our time. I'm just going to use this. Whee! Code gen, please. Code. Boom. Perfect. And then, boom. God damn it. What now? Why is it mad? What could you, also I just fixed it. Hey, chat, I fixed it. Are you proud of me? This has to say text width. I always forget that. Nope. It has to do something like that. Is it width? I can never remember. If anybody knows, let me know. Because I no longer know. RIP. But that is what we have to do. Because that is what was missing from our original. It's fine. Sir Aid says, is it on GitHub? This file? No, I wrote this like last night. Once again, not on GitHub. Because I'll take a look at it then. Lamau. It doesn't matter that much. It's a macro. It just saves barely any time when writing some things. Where are we at? Yes. Perfect. And go one more. Okay, we went back and forth quite enough, I'd say. Mini page. I know I did this somewhere else. Hey, look what I did. It's not optional. We did it finally. Okay, now is when we move it and do its own thing, now that it works. We could just do new environment, as stated, but I'm dug in at this point. /n mini page. #1, like that. Yes. Okay, one last try. Is everything still working? Missing dollar inserted. RIP. So this would verbatim is still being treated specially. And it's wrapping it is not going well. It's fine. Yep. Also verbatim should have same page equals true all the time. That would be nice. Why is this not at the beginning? See, that's our issue here. We didn't have mini page and text width and verbatim and same page. Jesus. Okay. Yeah. I forget mini pages have to be in their own paragraph. Lamau. No? Yeah. I was like, wait. No? Did I get it wrong? I got it right. Cool. I could just put this in the mini page. I could just remove it because it doesn't make any sense. Happens to me every time with tables, lol. It's true. Rightward drift. Okay, that's working now. Now. Imagine. We have the working example, right? Everything works. And all we have to do is do a little comment out. Where did it go? Do a little comment out. Place it with a thing. Do a little comment out. Place it with a thing. Please. No. Of course not. Runaway argument? Question mark? God damn it. Oh well. It's just because we have verbatim stuff within the as the argument, and it doesn't like it. Who care? Perfect. Mini page. Okie doke, okie doke. And code does not work. Because verbatim argument's sad. What verbatim package are you using? Fancy verb. And fancy header. But not for verbatims. Okay. Okay, so currently we now have code gen. And then we go, here's an intermediate representation example. So here's the code. There's a little bit of a weird white space here. We need V space after that. So maybe let's, I wonder if we can get away with not using the mini page for this one in code gen. Because same mini page guarantees it's on its own page, but same page doesn't always. So it did work. And it fixed our white space little issue here. And the generated AST of the program. See, I would like that in a mini page. That's when it's actually needed. Verbatim. Why? Stop. Stop. And this should get this all on its own page. Perfect. Okay, and then verbatim. So that looks like it overran the end of the page somehow. Why? Mini page shouldn't overrun the end of the page. It should go to the next page, but it can't do that. Well, that's an RIP, I guess. We'll take it. Yep, it's fine. And the generated AST of the program. This, I think it's extra fine because there's numbers. Sir Aid says it's one box, it can't break across pages. That's right, I always forget. I forget, so what's... But I thought it wouldn't break across pages. That was my point. My point is that it would start on the next page. But this didn't function properly. Because you'd think that if this couldn't fit on one page, I guess if it just can't fit on one page, then it won't work at all, is I guess what it's saying. So I'd have to split this into like 2 different sections, which I'm not gonna do. So we're gonna deal with the page break in the middle like that. The AST would be used to generate code by the code generation backend. Previously, this now gets converted into the following IR, excluding initial variable declarations only for the sake of brevity in the initial basic block. Here's the while loop body from our current program in terms of length scripts, intermediate representation, or IR. However, this diagram does not actually conform to IR. There's one more step to complete before it matches one-to-one conversion into static single assignment form, or SSA form for short. Static single assignment form. Variable has different values different times throughout the program, all with different lifetimes. They almost sound like different variables. Wait, what if they were? Each assignment of a variable after the first, creating a new variable, is the entire idea behind SSA, or static single assignment form. SSA form is a form of program in which each variable is not going to assign more than one time. Let's take a look at the example above, converted into SSA form. Jesus. I think that's all correct. And with this diagram, I think it starts to make sense. But it may not be completely clear to people what actually changed all that much. Should I talk about this? Should I say, like, as you can see, A1, has been assigned, so we create the variable A1. Should I go through in a specific example, like following E throughout the different control flows? I'm not sure. Either way, We can go variable liveness. Talk about things that are alive and dead. From the above static single assignment form diagram, you can begin to piece together the variables that are live at each point within the program or within some specific block of code. Okie doke. I still don't know how to do liveness analysis. I can't speak either. We could take a look at Sir Aid's IR branch and see if there is some liveness analysis that we can peek into, because I actually haven't seen any liveness analysis code ever. I would assume it's in register allocation. Could be wrong. Yeah, basic. Okay, platform interferer. Nice. This is new. This is new. I didn't see this earlier. That's awesome. I forgot where it was, though. Liveness ranges. They've got to be somewhere. Because we have to calculate the liveness of... Ooh. This seems a little messy here. Is this a switch within a switch? Oh, it's just dump value. Okay, I was like, wait, why are we switching on everything? But that's the debug printout. Don't worry about that. Saraid says, it's in ra.c. Okay, I just missed it. I'm going to search then. Oh god, okay. So we're using, perfect, values interfere. So where are our value ranges? Where are our live ranges, right? So we create an adjacency matrix of things that work together, like things that are temporaries that are needed at the same time, if I'm understanding correctly. Yeah, which webs interfere with one another. So that's a little bit different. So this is basically when we get webs of temporaries that can all be assigned to the same thing, we'll get multiples. So it's kind of like in math when you get multiple right answers, and we want to pick the best answer. So this uses an interference graph to figure out the one answer that we can use that won't alter many things. Okay. Liveness analysis, liveness analysis. Very cool. This is a cool API here. It's actually very cool. And then we can call a callback. Ooh, very complicated. It's in values interfere in friends. That's what I, so we were looking at webs interfere, were we not? Build webs. Values interfere. Okay, so for use, in uses. Okay, perfect. Yeah, so we have a use of a value. I don't really like the word use because it's hard to say, but there's not really anything else that you could call it, to be fair. There's not good English for this. So the definition and use of v1 are in the same block. If, okay, so v1 effectively refers to our value. So this is value 1 and v2, and we're checking if they interfere. So pulling us back, right, we can look at this PDF, and what this is referring to, this is perfect, this is perfect. Thank you so much, Sir Aid. Honestly, what might be a good thing to do is this. I don't know how this is gonna look horrible for you for a second, I'm sorry. We're figuring it out as we go. That's not too bad. How's that? Big chunky white bars. It's fine though. Okay, so for use, I can. Okay, this iterates over each use in v1. Okay, so it seems like at some point we've calculated liveness ranges into uses. I'm curious where these uses come from, and if they're Oh, I know where they're, okay. I'm starting to put it together. I saw something earlier. I know it now. They're from ir.c and then or codegen.c, are they not? Doesn't codegen.c deal with that? The uses are stored when the IR is generated. That's right. There's like use in ir.c. I'm close. I'm close. Okay, so I'm pretty sure I saw something like use. Yep, so you can say a value mark used by parent. So we will get a use, which has a parent, a next, and a uses. That's basically a linked list, I'm pretty sure. And the idea is that a value can be used by a parent value. Oh god, excuse me. Sorry, it says it is a linked list. Good. So we can mark a value as used by a parent. And when this happens, we can, like we said earlier, A is used by A1 is used by D1, right? So D1 would interfere with A1 because this variable reassignment of creating D1 effectively uses A1. So the fact that this use relationship occurs means that here, here, right, in values interfere, when we loop over the uses of value, then we will say if value 2 happens to be D1, right, then 1 may be used by D1, so these values do interfere, which is what this little piece does here. So it looks like a use is, so all of the intermediate representation instructions, similar to how we numbered these here, they will get their own numbering system called instructions. So each of the IR instructions will get an index. And then to compare two things, we can just say, is the index less or within this range of indices, right? So we can say, oh, this is alive from 2 to 7. This is happening at the basic block level, remember? So it would be 10 to 11, 11 to 12, 10 to 12, 10 to 13, 13, right? So with this, oh, this is cool. We're actually starting to understand it. So, oh boy. Why is there an else? So the definition and use are not in the same block, then this means that we cannot actually just use the simple instruction index within the basic block. So Raid says, yeah, comparing indices across basic blocks wouldn't work. And that's what this if ensures. This else is very separate from this if. I was like, wait, where does it go? But I get it now. The definition and use are in different blocks. So check if the definition of V2 lies between the definition of V1 and the use. I think I'm starting to get this. So if D1 lies between, so I guess these are in different blocks. So let's say we use E over here, and this one, that's simpler. F times 2 times E1 and 15. So check if the definition of V2, let's say we're checking if F and E1 are compatible. Let's just call this F for now. Check if the definition of V2, so if F has been declared, is this a declaration or a definition? So does definition refer to an assignment? Because that's what definition would mean to me, like this is a definition. For computing the interference graph, we only check if a value is live at the definition point of another value. So that is the assignment point. Definition equals assignment, more or less. Okay, that's what I had in my head. I just wanted to make sure this wasn't declaration, and I was screwing things up in my head. So this definition is here. So if F has been assigned to, so let's say it's being used here. So this is a different control flow. I get it now. The use of V1 has to follow the definition of V1. Yes. Our parser ensures that, not necessarily in terms of the instruction index, but certainly in terms of control flow. For which reason we only need to scan forward from the definition of v1 to its use. We return 1 if we follow the control flow. I saw that earlier, but I don't see it now. I'll find it. Perfect. You think it'd be harder for me to get lost in a... It's all the way at the top. Ah, I see. That's why I missed it. So we have a basic block pointer. So this points to a basic block pointer, and that's blocks visited. So I assume that our basic blocks are all in some flat list. They don't look like this. So for example, this would be the 0th, the 1st, the 2nd, the 3rd, and the 4th within an array. And this pointer keeps track of where we are so far. This is basically a vector of basic blocks. I'd say it's more like a set, but it is like, he said like a standard vector from C++, which is probably a set, because most of the time in programming languages, vectors are sets. I don't want to use too many linked lists. Yeah, that's fine. Sets are okay. So then we say blocks visited count, blocks visited capacity. So this is the max amount of blocks visited possible. And then we just iterate basic blocks as an array until we reach capacity. Conceptually, like a standard vector, I mean. I see. I honestly don't know what a standard vector is. I'm sure it's a C++ thing. I haven't used it. Is it like a Python vector where you can like push and pop? You probably can't pop atomically. That's probably not a thing that can happen. So you can't pop, but I'm sure you can push to the vector. Standard vector is a dynamic array. Yeah, okay, that's basically a vector. It's mathematically, though, it's a set, which is confusing. A vector is a fixed size. So, well, most of the time it's a known size, not a fixed size. So it's effectively a set where it can have any amount of items within it that it may also be sets. It's not a set. Standard set is different. Oh, so it can have duplicates. A vector can have duplicate values. Okay, that's where we're at. Okay, I get you now. I'm getting you now. Ooh, Emacs zoned out on the PDF. I didn't know this would happen. This is cool. I mean, we can change to that at any time, but can you imagine editing a PDF like this, by the way? This would be insanity. I don't know if anybody could ever understand this syntax. It's so confusing. There's literally just bytes. You know, just literal bytes in a file. So funny. PDFs are weird. PDFs are partially binary, so yeah, that's a rib. Okay, so effectively, to follow the control flow, we create a new context of iteration with the current block, a callback, and a list, an argument parameter list or whatever. AP. I don't know why it's AP. What is AP? Arguments passed? Arguments passed after the callback are forwarded to the callback as a VA list. No block is visited more than once. If the callback returns a non-zero value, the iteration stops. Return 0 if iteration completed, or the return value of the callback if the iteration was stopped. So in vfollow control flow, check if we have already visited, add this block to the list, copy the VA list, call the callback with the copy, return result if it's non-zero. If block end type is a return 0. If end type is a branch, block equals block end branch target. We're gonna want some braces around these, but it's okay. Block end type branch if follow both of the control flows, returning 1 either way. Oh boy. Sir Aid says you can write PostScript by hand though. The libc documentation always calls it app, so that's what I usually use, lol. That's fair. A more descriptive name may be better, but this is fine for now. I just don't know what the more descriptive name would be. Arguments, we could just call it like pass-through, right? Or we could call it callback args, I guess. We could call it forwarded args. There's a few names that give us a little more context on how it works. So this follow control flow, how does that make any sense? Now I'm more confused. So follow control flow, if it equals 1, that's what it said it would return if it didn't complete the iteration. Yeah, that's a return value of a callback. So what callback are we calling? Values interfere callback. Here. Returns. Oh. Don't you be doing that, Emacs. Returns 1 if the two values interfere with one another, 0 if they do not interfere in the current block, and -1 if they cannot interfere. So by checking if it equals 1, returning 1, then this means if they interfere, they interfere. This is starting to make sense now. And the callback, how do we check if they interfere? That is similar to what we were looking at before. If the definition, so if the assignment is in this block and precedes or is the same as the use, oh boy. A definition, so an assignment that also uses itself is killing me a little bit here, but I'm sure it makes sense. If def value, so this is definition. In this case, it's the definition of v2 and the use of v1. Should have probably added that. That's starting to make more sense. That makes much more sense. I was like, the definition is the same as the use of the variable? What? And then I was thinking like, maybe we would have like nested declarations? I couldn't even know. That makes a lot more sense. So this use value is, yeah, a v1, and the definition is a v2. So the assignment of v2, like let's say v2 is f or whatever, or let's say it's e1. Yeah, let's do that. Then this definition value would be this thing here. And I guess it's a value pointer, so this would be, I'm not sure if it would be the binary operator or this entire assignment expression. Either way, it points to expression 12, effectively here, right? In this block. So if the parent equals block, so if the use value of v1, so if we're like getting f here, if it's parent, I'm not sure if I'm following parent correctly. Parent might be something else. If it isn't, that means that it would just be the if condition block. And this if condition may be part of this up here, but I think that in the condition would be separate. The if would probably be part of up here. Not that it matters. Sir Aid says the parent of the use is the value. The parent of the value is the block. Okay, beautiful. Thank you, Sir Aid. Thank you. So we have this cross-platform thing called a value, which we're assuming could be a register, could be a... No, this thing called a value isn't like that. This value is actually referring to types of IRO instructions, if I remember correctly. So use value parent refers to a value. Yep, an actual value. And use value def value parent refers to a block. That makes a lot of sense. So this has a parent of a block. This has a parent of its value. Because that's a use of the value. So a use of f. and a definition of f, right? Yeah, this is starting to make sense. A use of f and a definition of b2 or whatever, some other thing. Sir Aid says, value here is a single IR instruction. Value equals instruction. Yes. This is slightly confusing, but it just refers to the return value of the instruction, which is why it's called value. We may want to consider changing the nomenclature a little bit. Because values tend to refer to like the value of a variable rather than the symbol. Sir Aid says essentially, yeah. So value here we may want to convert into something like IR instruction even, if that's all it actually is. If we just called it IR instruction. And then in the backend it would probably make a lot more sense rather than looping over values, looping over IR instructions in basic blocks. I think that makes sense. Yeah. This is pretty beautiful. I'm starting to get it. If they're in the same block, we can just compare index. So for example, A here, like if we're checking A and D, A would be the use. So the parent of it would be the value of A. The definition, which is this D thing that we're checking for the second parameter, has a parent of this block, and this equals the block that we are within, because A has also been defined here. Oh, that's beautiful. Okay, so if the use is in the same spot, I think I have a slight misunderstanding here, but I'm starting to get it ironed out. King Bun says, hello, finally back from work meeting. It's so good to have you. We are still talking about this little diagram here. So, but we're looking at actual code now and figuring out how it works. So the values interfere callback is called on every block. Is called on every block in this control flow. Seems like it makes sense. So then this callback, is it called for every follow control flow? I'd have to go look at that again. No block is visited more than once if the callback returns. Call a callback for each block. Yep, it's called on every block definition between the definition of v1, the definition and use of v1, or the definition of v1 and the definition of v2, whichever comes first. Okay. So basically, every block definition between the definition and use of v1. So let's fix our values so we can do some mental debugging. v1, I don't know when this would actually be called, to be fair. So we mark everything used by an ir.c. So for example, an add function argument. The argument is used by the call. That makes a lot of sense. That's this is very readable. So for some basic block stuff here that I'm not fully aware of how it works. Attach a block to the current function. So we basically create branches between the basic blocks in case we want to reorder them. I'm getting it now. Sir Aid says binary expressions are maybe a simpler example. Nice, yeah. So add. So you can see that the left-hand side and the right-hand side is used by this sum value. And then this sum is in the context or whatever. A basic block always has to end with a branch instruction. Yeah. Either a return or a if branch or something like that. Which is why I was talking about earlier, this if would technically be in this basic block, but the input condition would be in its own because it's its own thing. that gets executed, and then that would have to go its own way. King Bun says, did y'all see they finally made Minecraft in Minecraft? Did they really make a redstone computer that runs Java? That'd be pretty pog. Or did they just, are you talking about like command blocks? King Bun says, not Java, I don't believe. Interesting. It makes sense that they wouldn't run Java. Wonder what they wrote it in. They developed their own redstone language. Cogent multiply to do trivial constant folding. Yeah. Basically, if it's 2 times 3, then just create an integer node of 5 or of 6. Lamau, look at me get 2 times 3 wrong. Or if it's a divide of like 20 and 4, then just replace it with the integer 5 node instead of doing all this. But that's what this constant folding is talking about. In any case, so you can see that the left-hand side is used by the sum. So if we did b plus c, for example, right, then this binary operation of plus would use both b and c. So let's look, let's look at b1. So this, let's look at f. I'm changing my mind. It's simpler. It has a literal. Yeah, so effectively, what we would like to say is if v1 and v2 interfere. So this binary operation of b plus c, let's say that's a value, right? And then let's say that the use of it is when a1 is used, a1 here. So we're trying to use a1, and we would like to see if we can store d1 in the same register as a1, basically, right? Yeah. If they interfere. They don't interfere. You can store them in the same thing because A is now dead after this point. So effectively, Sir 8 says, ah yes, let's implement a JVM in Java. Nothing wrong with that, lol. It'd work. King Bun says 8 kilobyte program memory, 6 kilobyte graphics memory, 256 bytes of extra RAM, MISC RAM, I presume. The program itself was written in URCL. Oh lord. It was developed on a modified build of the URCX emulator before they put it in the game. That's insanity. Here's parent. So we have a use of A1, its furthest use. Again, if they're in the same block. And, okay. The definition of V2 is also in that block and lies between the definition of V1, V1's use, then V1 and V2 interfere. So if we had, again, A1, D1, A1 has a use here. So we are checking if D1, let's say, as V2 interferes. So the definition of V2, this D1 assignment, expression 11, is also in that block and lies between the definition of V1 and its use. Okay, so there's supposed to be an and in there. I get it now. So if the definition of V1, which is A1, our left value, right, lies between the definition of V1 and its use. So V1 is A1, so its use is here, its definition is here, our value is here, V2. Is that in between? Yeah, there should be an and there. Haven't had time to proofread the comments, Lamau. It's all good, I was just making sure I understand it. Nobody is perfect and pobuddy is nerfect. So effectively they're in the same block. So if the instruction index, so if the parent equals the parent, yeah, because the parent of the value is the block. So ensure they're in the same block. and ensure that v1, when it gets created, like a1 here, is less than v2. That's true, it's above. And v2 is less than or equal to the block? No, that's the block. So the use parent is a value. So the use of instruction index, so if it's equal. Okay, so I'm starting to get it now. So let's say this is all one instruction. I don't know if it is, but let's say it is. So v2's instruction index would be 11. The uses index would also be 11. So that would be the equal case. And then v1, the definition of v1, this is starting to make a lot of sense. So v1 being defined before its use is necessary. So we're saying basically if the use is within the idea. Yeah, if the use of v1 is in the same block, the definition and use of v1 are in the same block. Otherwise, we have to follow control flow. Sir Aid says, since the register allocation is not complete, there may very well be bugs or logic errors in here. So take everything with a grain of salt, okay? Yes, I'm trying to reason through it just to get acquainted with liveness analysis and how we're actually implementing it. Because I can start to understand it, but I can only start to understand it, right? It's not, why is it budged up? Okay, so effectively, with static single assignment form, so we should probably just include all the variable declarations above. We should, like, all of these, because that's kind of important. Doesn't matter, though. Everything being named parent is probably confusing. Well, yeah. It's killing us a little bit. I understand it, though, because it's like the same thing in Lisp. It's like, oh, car, cooter. That actually refers to the environment. It doesn't, but it's just an example of, like, when you're dealing with a data structure that is dynamic, you have to deal with names that aren't specific. Totally understandable. I think the only way to do this would be, like, extract each of these dereferences into a variable declaration so that you can see the type, a named variable that has something to do with what this refers to, and then actually where it's gotten from as well. But these are all refactors for readability, not for functionality. So it's not like I'm going to make you do them before we merge this bad boy. So if we understand each other correctly, a web refers to a bunch of things. Yeah, adjacency matrix. Yes, we're getting there. Build webs. Perfect comment right here. Sir Aid says, I mean, when I look at the code, my IDE shows me the type, so I usually don't have that problem. True. If you like unreproducible build systems, then Sir Aid is apparently your boy, your guy. No, I'm just messing with you. And I know you're just messing with me. But instead of relying on IDE features that are very hard to implement and resource intensive, and really not everybody has them. Hint, hint, nudge, nudge, me. I mean, I could have them. I use Egglet, and I could have inline type annotations. I just hate them because I don't like my buffer moving around when I don't do it. So, effectively, we should try and make it readable on a plain text level rather than on a IDE level. But yeah, Sir Aid puts it perfectly here. We don't need to assign a register for each value. Certain values overlap and can share a register. That's what we were talking about. A and D can share a register, even though they are separate values. So this is when we're starting to do register allocation itself, hence we're in RA.C. Right? Right. Okay, so I'm gonna add some things to the tech, which is talking about variable liveness. And the idea also to do would be describe like basic block. Yeah. To do basic block function value, etc. definitions. Vocabulary definitions. So we want some sort of list here with like basic block, a list of values, right? Which are really IR instructions. And then stuff like this. I'm gonna add that to the to-do and put that in a comment. Variable liveness. We can say that the variables that are, also I need visual line mode, please. From the above static single assignment form diagram, we can begin to piece together the variables that are live at each point within the program. As humans, so the problem is this isn't how the compiler works at all, right? So the compiler, this bad boy, to do liveness analysis, how's it done? So liveness analysis is done by keeping track of every. So it says also, like I mentioned, if you want to see this part of the register allocation in action, you can just run it and it'll print the IR, webs, and matrix. Ooh, then we'll definitely do that. Liveness analysis is done by keeping track of every use of a variable in a, we're just going to call it a list, in a list of use structures. Pronounced. How do you do use? Pronounced with, what is it? With snake-like S. You know what I mean? I want to make sure people don't say it's a use structure. It's a use structure. Liveness analysis is done by keep track of every use of a variable in a linked list of used structs. Structures? Structs. In any case, this is done while generating at the same time as generating, we'll say while. We'll say during intermediate representation generation. Effectively, we build our IR with live ranges built in. Is this use as a noun so the S is voiceless? I like that. Pronounced like the noun. The S is voiceless. I like how you said that. Also, I wouldn't really call them variables because actual local variables are currently still being handled by doing loads and stores. We currently don't have a mem to reg pass or something like that. Right, so we've talked about that, where explicitly, the only places that it happens are explicitly. But you're saying a local variable accessing the value of it, even without a pointer or dereference, will still use stack memory. But that would effectively, I mean, that's kind of how it works anyway. That all depends on like calling convention and dealing with each specific platform, right? So won't mem to reg have to know which registers, like arguments to the function are stored in and stuff? It's going to be a very complicated mem to reg pass. And there's not going to be just one, I guarantee it. But yeah, that's optimization we can do in the future. So he's saying we shouldn't call them variables here. Each use of a calculated value, of some calculated value. It's done by keeping track of every use of some calculated value in a linked list of use structures. Memtorech would basically split a variable into separate values like your E1 and E2. Right. And those values would then hopefully end up in registers without using the stack, but it may spill. I totally get it. I'm getting it now. Sir Aid, your ways have infected me. I am now starting to understand. Also, when would we ever spill? Because isn't like almost every graph like 5 colorable? Haven't we discovered that? Isn't that NP complete or something? King Bun says, at least one of us is Linzer. Lamau. Sir Aid says, yeah, if there's too many values, we may have to spill or rematerialize. How would we ever get too many values? You know what I mean? In use at the same time. A graph is k colorable if none of its vertices have k or more edges. How would we end up with 16 edges? I know what you're talking about. How would we end up with 16 edges? I'm truthfully curious. I love that you just know that. The graph theory definition of coloring. You're like, it's only k colorable if none of its vertices have k or more edges. So I'm thinking of maps. That's what I'm thinking of. Maps are like 4 or 5 colorable. And maps are a specific type of graph. So if none of its vertices have k or more edges, I just am having trouble. When would we ever have more than, like, even if we had a ternary operator, even a quaternarian. Sir Aid says, we probably won't. That's why this works. Lamau, that's a good point. Sir Aid, with the quickness once more. King Bun says, everyone should casually know all of graph theory like that. It's true. Okay. So 2 values A and B can share a register if A is a phi node of B, A is a phi node and B is an argument of A. So what is an argument of a phi node? What's a phi node? To do, optimize this. It's all. Oh no, is this a mem to reg pass that I'm sniffing out? So we're gonna go to ra.h, I think. What do we got? Allocate registers, that's it. Okay, ir.h. So we have a function, which is basically a list of basic blocks in some order. And function is a linked list. It has a pointer to its return value. Value count, which I'm sure is the max, the amount. So this is like a rope where it keeps track of all its children's lengths. If we have phi block 1, R1, block 2, R2, the arguments would be R1 and R2. Okay, I get you then. So how are, ooh, I hit that in the wrong thing. So how are then, ooh. Value count is unused now, actually, I think. I see. So it's not like a rope. Basic block predecessor. What? Have to figure that one out. Basic blocks that branch to this one. This is used for control flow analysis. This is basically a parent. Basic block has a function parent. So you just couldn't call it parent because... So why does it need next? Doesn't block... I see. So that doesn't refer to the parent's next, I'm sure. It refers to something else. Okay. Predecessor is actually what it's usually called. I see. Well, yeah, it just means something that came before the current block. But it's basically... Wouldn't next just point to the current block then? Right? So it seems like it's not exactly a predecessor. It's like a previous and ancestor. A predecessor. The last value in the linked list and size t ID and char closed. I'm not sure what those two are for. Linked list of values. So in a basic block, we have a linked list of values. In a function, we have a linked list of basic blocks. Do we? We have an entry and a last. Entry is next and previous. So the function linked list is kind of stuffed into a basic block. A basic block has a linked list of values as well. So there's kind of two linked lists stuffed into this one struct. ID is for the backend, and closed is to make sure you don't have more than one branch in a BB. In a branch. It's a lot of linked lists, I know. Oh, it's not an issue. I'm just wondering if we could possibly delegate some of these into function itself with entry and entry next or something like that. But basic block has to know its next so that we can go to its next and etc. And parent is needed to get to the, yeah. Okay, I think you're right. These are the proper structures. BB equals basic block. Bless. Look at that value struct. It's horrible. Where is it? Function call args, variables. Did I miss value? Isn't that at the bottom? Yeah, here it is. This is, without a doubt, one of the most abominable structs I have ever designed. There has to be a better way of doing this. Perhaps splitting it into separate structs would help. So we have an IR instruction. We have a parent basic block that it is contained within. So value is a value within a basic block. It has some instruction index within basic block. Yeah. So already I can sense that like this instruction index could be in another little structure with a value. So you could have like size t instruction index and value as the two members of a structure. And then that structure could actually be your list of values here. And then that structure could also contain the linked list stuff of next and prev. If that would work, it would require a lot of extra code to change. A value often needs to know its own index, so it's easiest to store that in the value. The real problem here is that union. It's not too bad. Just this is a little interesting. This is okay, that's where it gets a little iffy. I think all this is fine. It's like, okay, we just need different values for different pieces, right? Sir Aid says, told you it was bad. Yes, you did. You did warn me. So we have an unnamed union with the value of an unnamed structure, which has two values, a left-hand side and a right-hand side. It's currently 104 bytes. Yeah, that's not the best. Not the best. That's horrible. It's fairly horrible. Even if it was 128, it'd be better. You should make it bigger. Get memory alignment, easy arrays and stuff. Sorry, it says, I'll refactor it once register allocation is done. No rush. It doesn't even need refactored if it works. It's just messy and we can slowly figure out how to refactor it. It's not imperative that this is fixed. Used by the backend. What does that mean? So will each backend, will this just grow? Like, could we have a structure? King Bun says, okay, question. Perfect. Our first question. I thought there would be many more questions today, but we've been going well so far. What's up, King Buns? What's on your mind? Sir 8 says, no, that's for the register allocation, etc. mostly. Okay, that makes sense then. That's why, okay, I'm getting you now. Backend in this case means the code that does post-processing and register allocation. So you're talking about the middle end of the code gen backend, of the code gen front end, right? You're talking about the back end of the front end of the code gen backend. And the optimizer as well, once we add one. Yay! King Bun says, why do some places insist that you use uint32 for like every data type, including characters, so they don't really just care, so they don't really just char types in their code, but other people don't follow that at all? There's a lot of reasons, King Buns, and it's none of them matter. Do whatever you want. That's the real answer. But to answer your question, the reason people say that, King Bun says, okay, bet. The reason people say that is that, see this node structure? The pop-up at the bottom of Emacs, I can't mouse over it, it may go away. The pop-up at the bottom you see on the left here, just below my mouse. It's 40 bytes. So node being 40 bytes means that if you have multiple of them in an array next to each other, all of the accesses will be 8-byte aligned, but not 16-byte aligned. Right? Does that make sense? So the fact is, if you have a character, right, within a structure, where are we at? Right, like over here, right. What is the benefit of 16-byte alignment? We'll get there. So if you have a character here, like value, right? Or a structure here like value, it has characters at the end, which means it's not going to be 8-byte aligned if you have multiple of them in an array. This doesn't matter currently because it's not stored in an array. We never have an array of values. They're a linked list, so it doesn't actually matter. King Bun says, oh, because chars are 1 byte. Exactly. So our structure, like if you had 3 at the end, then it's actually like 43 bytes long of a structure. Then you can see that's no good, right? Like if we had some new A and B, then you can see parsing state grows to 16 bytes. Even if I remove one. 16 bytes. What's going on, King Buns? King Bun says, so you kind of throw your memory off. Kinda. But look at what the compiler does. So now it's 16 bytes. But I'm going to add a new character. So that should be 1 extra byte, should be 17. And it's still 16. This is because we have, again, this isn't proper for 8 bytes. This should be double. So we have 8 bytes here, because it's a pointer. 8 bytes here, 8 bytes here. So there's 24 bytes. So this would be 25, 26, 27. But the compiler says, nah. You're not allowed 27 bytes in a struct, because then as you're accessing these, they're all going to be at slow memory accesses. They're going to be not aligned. And the argument is that x86 64 is supposedly more optimized to read from 16-byte memory boundaries, memory address boundaries. It is, x86 is supposedly more optimized to read from 8-byte or 4-byte, right? So Sir 8 says, yeah, essentially C always pads structs to the alignment of the struct. Correct. And it keeps the alignment of at least 4 in most cases. King Bun says, so how does it go down to 16 bytes? What does that mean? How does it go down to 16? It never goes down, it always pads it upwards. So currently this would be 12 bytes on a 32-bit system, as it is telling me, right? 12 bytes. But once we add any amount of byte, a byte here, right? Then we go here and you can see it's 16 bytes now. So it should be 13, but it adds in invisible padding, right? And this invisible padding is there in this structure. You can see it does not change the size by adding these invisible padding bytes. King Bun says, oh, I thought you were saying it was 24 bytes. Yeah, we're going between 32 and 64-bit. So on a 64-bit system, a pointer is 8 bytes, so each of these would be 8 bytes. But on a 32-bit, a pointer is 4 bytes, so each of these would be 4. So it's either going to be 12 or 24 bytes for these pointers. And then as we add characters, characters are always 1 byte. The 12 bytes is assuming that we're on a 32-bit system. Yep, because for some reason Emacs thinks pointers are 4 bytes. Emacs doesn't think anything about pointers. That is clangd. King Bun says, beautifully explained. I thank you all for your help. I'm glad we could help. I am very glad. Yes, yes. I forgot what we were talking about. We were looking at this. So effectively, each of these things is a value. It can be a whole bunch of things, which is a mix of pointers, literals, and structures, and unnamed structures. Arusia says developers.pdf. It's true. We're writing developers.tech right now, which we're going to push to the GitHub. Then you can build your own PDF and see, how does this thing actually work? Right? How does this language work? And the idea is that it will be at least somewhat understandable. Soraid says, also according to the standard, char doesn't have to be 1 byte. It's just everything would break in every program ever if it wasn't. It is perfectly legal for a system to define char, short, int, and long to all be 4 bytes long or something like that. That's why some people prefer uint32t, etc. over unsigned. And in like OS development or hardware interaction, that matters. Arusia says, PDF is bloat, just read the text. Lamau, just read the text. King Bun says, I will be a great test case for reading that. Awesome. Yeah, just let me know anything that's confusing, any problems you have, I'll try and address them. And obviously ask any questions as we go. Should I just push this? I could just push it. You haven't touched docs, have you, Soraid? If you've touched the docs, this is going to hurt things. Hopefully you haven't touched docs. Soraid says, nope, perfect. Can I look at the... able to merge... 15 files changed. Which files? I know we should probably just do a thing. So we have cmake, cogen. So I should just do this. Just making sure that we won't create any merge conflicts with our upcoming pull request. Error, parser.c had to get some changes because we had a new node type, which is a local variable. So now locals are different from variable accesses. What is this? Local variables are now handled differently. What does that mean? Struct value result. Yeah, that's perfect. Create a reference to a local variable. This means a variable access of a local variable. Instead of storing a stack offset, it now stores a pointer to the IR allocate instruction. We really got to change that to stack allocate. I hate allocate. It's not growing on me. It's growing away from me. Instead of storing a stack offset, it now stores a pointer to the IR stack allocation instruction. Oh, I get you. I get you now. Equals variable. But what do we pass to node local variable? When is it called is my confusion. Node local variable. We never call it in parser.c, right? Am I just not looking at parser.c? Oh, I'm looking at it. It never gets called. Maybe it's just a work in progress and it's not done yet. But it seems like it should be called. I think it's in ir.c. That's a little messy. I understand, I understand. We have it open. Sorade says, yeah, but it's also work in progress. True. So, what was it called? Node local? Local? Local reference? Local value? Store? I didn't see it. Maybe it's in your local branch. You haven't pushed it yet. Or I just haven't refreshed my page. Lamau. I'll have to like grep for it. Where does this bad boy come from? In any case, you didn't touch docs. I'll be fine pushing to docs. Make sure that we are all pulled. It is in codegen.c, my bad. Okay, it's codegen.c. So codegen.c somehow creates a value for... So codegen is meant to create an intermediate representation. Where's codegen.c? Why? What just happened? And this just takes me here? I can't go to this file? Copied? No, take me to the file. God damn it. GitHub. Why is it under a button? What does clicking on it do? Just jump to it? You can click on load diff though, but then it's just in this giant page of diffs that I don't want. I want to look at this file. Sorry, it says, thanks, GitHub. Exactly. It's like, oh, good. Good thing I can jump to right here. Oh, good. Good thing I can click on this link that goes nowhere. Oh. Local variable access. What? Okay. We're gonna look at locals. Define node integer, static assert 0. What? Ignore that. Cut that, cut that, cut that. I knew that was not supposed to be there. I was like, hey, I see something I shouldn't see. I feel like a little kid stealing candy. That's just to make sure node integer isn't used in the file. Well, it's a good idea. I wish you could, there was like an in-language way to do that. So what am I looking for now? Like underscore local, right? AST should never contain local variable nodes. Then it's arguable they shouldn't be nodes at all. But I'm sure there's a reason. Cogen load. Define. Surade says that macro is the easiest way to define the compiler, to make the compiler in my IDE tell me where X is used. It's true. So now we see uses of node local variable during a variable declaration. And we pass in variable. Pass in variable, which is from our stack allocate function. So our stack allocate function returns the actual stack allocation. Yeah. Sorade says, I implemented whatever changes I needed to get it to work, but that's about it. Yeet. So I'm just wondering, so node local variable, why can this not be a value, an IR value? Emacs is being weird again. Wow. It's zoning out. It's doing puts with case. There we go. It's back. It's back. Okay, so in docs, we want developers.tick. This should not be an issue. There's a lot to do, but we're just going to commit it so that if anybody wants, they can go to the GitHub and read about our little language here. And we're basically going to say what? Docs create developers.tick. We outline the inner workings of the compiler. This should drastically help newcomers understand our complex code base. All the way from parsing, lexing, parsing, type checking. I'll say all the way through. And code generation. Interesting. It goes right up to 70. Sir Aid says variables should be stored in the IR, and that's where they will be stored. It's just that I haven't gotten to that part yet. That's all cool. I just wanted to make sure that this being a node was known that it may not need to be a node unless we're doing our IR within the node structure. But don't worry about it. If it works, just keep it working. We'll refactor it, right? Maybe make a comment that says like, this doesn't need to be a node, this could be an IR value, and then we can move on from there. So it says codegen.c still needs some more refactoring, but right now I'm focusing on register allocation, so I'll get back to that once that's done. Awesome, awesome. That's very cool. Yeah, don't feel rushed at all. This whole section of code is pretty non-radical, dudes. It very much is very non-radical. Also, our dereference codegen is still completely broken. That's something we have to fix, like, fast. Because dereference currently does nothing. It's so disappointing. When I look at the fact that I wrote that, it's like, no, why would I write this? This is dumb. I don't know where it is, but it's somewhere here. And it's very wrong. I can guarantee it. Access, declaration, binary. That's probably an if, yep, that's a index. Dereference. Look, we just code gen the child and then go, yep, that's all, that's all. Isn't that fun? Isn't that fun? So dumb. I can't believe I wrote that. Sorry, it says lol. It's true. It's like, what is this? This doesn't make any sense. Why did I write this? It's not on Sir 8 at all. I wrote this 100%. Sir 8 says, didn't even realize that, lol. It's true. Apparently I didn't either, sadly enough. It was just like, yeah, you know, just get a pointer, and that's all that matters. Just return a pointer from dereference. Why not? But that's why everything is breaking in our arrays example, and the return value is not correct. See, we have an unmerged, so we're going to push, and we're going to hope that this doesn't change this little able to merge bit here. Hey, we can still automatically merge. No merge conflicts. Hooray. And the compiler, at least in my fork, on the main branch, now has developers.tix. And reference.txt if you're interested in the language, but it has developers.tix. I wish they just showed the PDF on GitHub. I don't know why they don't support more, like, readability. It's fine. I know that's a complicated thing, but like Wikipedia has been doing it for tens of years, for decades, rendering LaTeX inline on their web pages, and it's not a big deal. Sarade says you can check out the IR branch if you want to see what it does at the moment. Let's do it. Let's do it. Yes, I know. Uh-huh. Uh-huh. IR. Yes, it's fine. Where is it? Shouldn't the little thing that gives me the... Let's do this. So I would like to clone a Git repository. Maggot clone. Also ignore the fun compiler directories. It's not important. Clone from URL. No, this thing. Why did we not keep it? Also, I screwed up just then. Sorry, it says Lamau. I think Wikipedia just has single tech expressions in line. Your tech document in Git could consist of multiple files with all kinds of packages. I mean, they already have CI/CD. They already run things like complex programs. All they have to run is PDF latex once on it. You know what I mean? I understand what you're saying, though. It is more complicated. I shouldn't compare it to Wikipedia. Clone from URL or name .git. Clone into fun compiler IR. Sure, I don't care. And look, we've done it. It's happened. Okay, yeah, it's happy. And now in here, we should be able to do some things with CMake. We would like to generate Ninja. We would like to, oh god. We're just gonna say CMake build type equals debug, just in case. And then where? Where is this? So this is going to be in build. Should use 10.3. Yeah. Okay. That's looking good. Now we can build this. Also, for people who say CMake is hard to use, was that hard? That was real difficult. No, I'm just messing with you. Then we can use build and run our little executable on an example. I don't know why I always pick pointers, but I do. And it apparently still generates code, so let's take a look at it. Are you on the right branch? Oh, I'm probably not. Did I just pull the, yeah, you're right, you're right. I gotta do that. Yeah, it's fine. Control-X-G. Bless, Sir Aid, by the way. I don't do, I don't do branches very often, if you don't know. It's kind of a branch. Check out branch, origin IR. I always forget to check out the branch. So this should now be proper. Perfect. Assertion failed. So good. I wonder if that's -v. Yeah, that's -v. Use a different example. Suraid, nah, it was me. I was trying to use verbose. And when we print out node, so in node text in the parser, there's another assert that you missed. That's all it is. Right here, in fact, is where it is, on line 265 of parser.c in function node text. And this is an incorrect error message as well. If you want to fix that assert message, that'd be great. It's just the -v flag breaking things. So don't pass verbose, and everything works. Oh, this is beautiful. This makes more sense. I was like, it outputs code? This makes much more sense. See, my shell displays the branch I'm on, so I don't have that problem. I mean, mine does too. I'm just not in my shell right now. Not mean. I'm in main. Very useful. Good thing I could see that I was on the wrong branch. I don't know why that's broken. Anyway, where were we at? Beautiful stuff. This is the intermediate representation. It looks suspiciously like LLVM. Very suspiciously like LLVM. I know it's just the debug output though. Basically, we have, why do we start at R8? Where's R1 and R2 and R3? R2 interferes with itself, it looks like. R1 slash through R7 are the physical registers in this case. The physical registers? Are those our scratch registers? Is that what you're saying? Wait, I'm confused. Shouldn't, this is LLV, this is an intermediate representation. Shouldn't we just have any amount of registers? So R1 through R7, the numbers are just for debug printing. I see. So these don't actually exist anywhere, these numbers. Then it doesn't matter if it's just for debug printing. It is confusing why it works that way. Because there aren't any physical registers. This is a lowered version of the IR. So the IR basically gets lowered into like a mix between assembly and IR, is what you're saying? And we effectively say this IR, this assembly has 8 physical registers and an infinite amount of virtual registers. More or less, yeah. All right, I'm starting to get it. Also, I'm tired of having this big on the side of my screen. I'm gonna do this. Yeet. So, ignoring register names, we can see that there is a function, not even functions, there are basic blocks, and the one basic block is this one, which has a function called the foo, it seems like, right? So we have a function called the foo. For instance, at the end it copies R1 because that's racks, and that's where the return value goes. Yeah, so this little debug output has its own hardware implementation. I get it. It only dumps the main function right now. I see. So the main function, I see, defun main, has 2 basic blocks, which effectively says what? We want foo to be assigned to this lambda. So this lambda, we need the address of this lambda. So load the address of function 0. Okay, that makes a lot of sense. So lambda 0 or function 0 needs, we need to get the address of it. This is weird how there's no function call syntax. You wrote it out in like English, and it's very hard for me to parse this in my brain. It's really funny. If you want to view the other functions, you can insert a call to codegen dump IR and register allocate in ra.c. All right, we'll take a look at it. So the actual body of this function we will never look at. Global store R8 to foo. So this is a store. So this would effectively say write to wherever foo is, whatever you've implemented this function as. Maybe it's some place on the stack. Maybe it's actually a register. Maybe it's anything, right? It's just some place that stores a value. So we store R8 to a foo. R9 is load foo. R10 says call R9. So this refers to all of this. Technically just this part, but it refers to all of this. Foo is a global variable. This writes the address of the function into foo. Exactly, yeah. We got it right. Foo is like a the implementation can be up to the backend, how you actually store this register. It could be another register that you store foo in, if there were infinite registers, right? Or it could be some place in memory, like in x86-64, we allocate within the executable.data section. Eventually, the label should just be foo. Ideally, yes, where __ function just refers to foo. Is that what you're saying? Or are we off? Are we off kilter? R9 says global load of foo, and R10 says call R9 with parentheses. So that's probably a list of arguments. So this is this function call. We load the variable access of foo, which we've just stored, and we call that register. That's fairly valid, I would say. LandoXT says, just coming in again to say, I gave you an invite to github.com/lendscript and all the other lang names. It's interesting that you've done that. R11 says global address of function 1. So that is the code generation for this lambda right here. The second lambda, aka the first function out of 0 indices. And then we store R11 in bar, so this is the same syntax as up here. Totally makes sense. And you can see how each variable starts to get its own name and such. R12 is immediate 0, so that's the code gen for this. Global store R12 to number, that's that. R13 is global address of number, which is this, and then store R13 to numputter. Totally makes sense. We never allocate anything for the global variables. So global variables are expected to be allocated by the backend in some backend specific way. This is making sense. Sir 8 says global variables will be allocated by the backend. Yep, okay. We're starting to understand each other. R14 global load numputter. R15 global load bar. Then we could call R15 with R14. That's exactly what we do. Store that in R16. We load number, global load number, which is our, these should be in like quotes or something to know that it's a variable name and not just more instructions. Because with the space separated syntax, it's so hard to understand what's going on. I thought this was like global load number. What number? So it says, yeah, perhaps, haha. We definitely got to work on this intermediate syntax. And then we're going to have to write an entire parser and stuff. Or percentage number. That's a little too close to registers, but I think that's okay. I just don't want to confuse it. Marussia says dollar number, maybe. That'd be the LLVM IR way. Lol. Yeah, we shouldn't stop recommending things just because LLVM does it. I'm not interested in doing things because other people do, as you may have, as you may already know, by my very conflicting, I don't know even what to call it, but my personality, which conflicts with everything I'm told to do. Like, oh, you want to do this? Why? And if you can't say why, it's like, well, we're not doing it. I'm just used to LLVMIR, okay? So even if I don't try to write LLVMIR, it sometimes just sort of happens, lol. Oh, I understand. I want you to recognize I'm gonna be, till the day I die, I will die on that hill of why do we do it? If you could reason like, oh, well, a percentage sign, it's just another place in memory or another temporary that we're referring to in a different way, so we could have a percentage sign. I totally would have heard you out way more. Right? But just suggesting what they do because they did it, it's going to be a harsh no almost every time. LVMIR actually uses at for globals, not percentage, my bad. lol. It's all good. See, at least makes a little bit of sense, because then it's at least they're trying to make it readable in some case, right? At indicates a global value and percentage a temporary. Nice. See, that's okay. I still don't think it's perfect. Functions also start with at. That's where that's very much not perfect. That sucks. Because they're in different namespaces, aren't they? In LLVM. It doesn't matter. It doesn't matter. I know it doesn't apply to us because functions and such are in the same namespace. Because functions are variables, but we'll see. Branch to BB0. Okay, so the exit of every function becomes a basic block so that if we want to return, we can just load our 17 and branch. Am I understanding correctly? Functions are like global constants in LLVM. Gross. The exit block of a function is a separate block. That's correct. So we can just load our 17 with the return value and then call. That's why there's a phi. So anytime another basic block is added to the function, then this phi would grow and say like BB2, if it also branches to BB0 at the end, then we would say, oh, it's in R20. So this would become BB1, R17, BB2, R20. How does that actually work on the backend level? How do you figure out? I guess you just have to ensure that all of these are mapped to the same register. The register allocation handles phi nodes. Let's take a look at it then. How does it handle phi nodes? I'm going to take a look. Where are we at? Not here. ra.c. Here we are. Yeah, it's starting to make sense. That's exactly my intuition. A phi node and its arguments are placed in the same web, if you recall. Nice. Yep. This is starting to make a lot of sense. So effectively, when we have our phi here, because there's only one block that can branch, then there's only one temporary it could ever be. So this is just R17 into R18. Again, an optimization case to be made here, but it doesn't matter. What is combine? Is that a label? Oh no. Is there a go-to? No! Sir Aid! I was like, wait, no. Sir Aid says don't worry about it. I'm very worried about it. This looks like it could just be a while loop with a continuation though. And then its return, it would have to set some flag on whether or not to break once it continues. Because if this happens, then you would break out of this while loop, and then if you would also set some flag that breaks out of this while loop. Arusius says goto considered harmless. Lol. Yeah, it's fine. Gotos are fine. No problems. I understand why it's being used here, by the way. It's just, it seems like the doubly nested while is, I think it's fine. Just set like an exit flag in the nested while, and then you can exit out of it, the parent while if need be. So basically, when we build webs, we're saying we don't need to assign a register for each value. Certain values overlap. A and B overlap if A is a phi node and B is an argument, or if B is a phi node and A is an argument, etc. If A and B are both arguments of the same phi node, so both R17 and R21 in my made-up example with basic block 2, and A and B are both arguments of a copy instruction, because copying something just gets you the same value. And then if we altered that value, it would create a new value, which wouldn't be A or B. Okay. So we build For each phi and copy instruction, construct a web. So if it's phi, basically say argument equals e value. For So for every one of these, for every value within the phi, so it says copy is a low-level instruction that's generated by the backend, by the way. It's mostly used to ensure that values end up in the right physical registers, like the return value in racks. Nice. So what you're saying is copy is never actually handled in the IR? Yeah. Interesting. Okay, I get it. So effectively, if we don't have a web already, or we don't have a web already for our argument, which is one of our values in the phi node, create a web, set the thingamajig, right? I'm saying that there's no way for you to generate a copy instruction in the front end. Exactly. Yeah, we're on the same page. We're basically saying copy is never actually used in this sense. It's going to be used by the register allocator, like you're saying, and the backend. Very cool. That's starting to make sense. So everything should already be built by the time we have copies in there, which means that this, yeah. So if we have, for example, our phi node, and R17 is not in one of its other arguments, then we say, hey, we have to all be in the same web, or at least have the same web. Right? So if they both have their own web, merge them together. A little bit of realloc. The confusing multiply in the size of. Please use parentheses. Oh god. This is a terrible syntax. Oh god. The multiply right next to the dereference, the same operator. It's really killer on the eyes, you know what I mean? It's like, oh, capacity times size of times, wait. Sorry, it says, I like size of without parens. So you just like these two things being in the same place but meaning completely different things? It bothers me so much. My eyes yell at me. What is this? I read it as value capacity times size of times phi web values. There's no space after the... White space doesn't matter, though. The sense is clear. I get what you're saying, but it's so messy. My eyes don't like it. It just reads this as one multiply by multiply by multiply. Because you can put 1 times 2 times 3 all next to each other and it means one thing. Know what I mean? It's definitely a semantic issue. It's just styling. But it kills me. My eyeballs. If it's not big enough, reallocate it. This is basically a vector. We just double in size every time it's not big enough. We may want to have this be its own little function for easy refactoring. Because it may be better to grow it by like 4 each time, and it is much more efficient rather than doubling each time. For size ti equals 0 is less than argument web value count. Phi web values equals argument web values. Makes sense. Basically, copy 2 values. Copy one list into another list once it's big enough. Remove the merged web from the list of webs. Yes, we have our old web and we're updating it with this new merged web that they're both going to point to one thing, so we can remove one of them. Any reason you're using calloc initially, but then realloc instead of realloc array? What? Calloc sets things to 0? Realloc just reallocates memory? I'm not sure. Suraid says, yes, didn't know realloc array was a thing. Is that like a singular thing? Realloc array? I don't think we should use it. I think we should use realloc and calloc in this way. Because this is understandable to like any C programmer. I've never heard of realloc array either. I wouldn't recommend using it. Because I've been programming in C for years and didn't know about it. And also I mainly use calloc even for allocating one thing because it sets it to 0. That was exactly my point as well. It zeroes out the given memory. Ah, the no parens is it's making my one arm heavier than the other, if you know what I mean. Calloc has two parameters, nmemb and size, and safely fails possible overflow of nmemb times size. What? I'm not sure what you're saying, Arusius. It just allocates this many of this many bytes. So I'm not sure how you would ever have an overflow if you're allocating the proper amount of bytes. It'd be the same if you used malloc. Sir8 says, a lot of the code relies on the fact that calloc 0 initializes it. Exactly. Like, if the web didn't have null pointers by default, there would be a bunch of null assignments here that have to happen every time, which would be a whole thing. So effectively, phi is just a way to merge multiple registers from our intermediate representation into a single register and allow everything to still work out on every level. This is starting to make sense. Which webs and registers interfere with one another? See below for a description of how registers and webs are mapped. A value of 1 indicates that the two corresponding webs/registers interfere with one another. So when we look at this, we can see that there are 10 webs. Most of them are single temporaries, meaning that we just get to use these directly. Also, this leading bit of space is killing me. Arusia says, calloc count size is essentially malloc count times size, but count times size can overflow if their values are large, and calloc detects that. What? If their values are large, it can overflow? Are you talking about integer overflow? What are you talking about? I'm so confused what Arusius is on about. I'm sure he knows what he's talking about. I just am I'm in a different mode. Yes, integer overflow. How? That's not relevant. I promise. It's not relevant. Integer overflow when using calloc. Not relevant. Not at least in this scenario where we're callocing one thing. How would this ever integer overflow? What are you talking about? Suraid says if you overflow during memory allocation, there's something else wrong with your code, honestly. That's what I would agree. I'm like, wait, how would you ever use calloc in a way that breaks that? What? This is... I'm confused how you think this could be unsafe. There's a literal integer and a size of bytes. Are you telling me if this is like a 32-bit, maximum 32-bit integer, that's what you're telling me the issue is? I don't think that's an issue with this code. That's an issue of having the size of be way too big. I'm just confused at how it applies to this situation. Assuming there are 3 webs and 3 registers, if webs w1 and w2, w2 and w3, r1 and w3 interfere, so how can a web and a register interfere? A web and a register. never interfere. We have webs to webs. We have registers to registers. But we don't have webs to registers. If you have a div instruction and you want the quotient, RDX would interfere with the div instruction. But these aren't instructions, these are registers and webs. So are you saying that the value, so let's say here, right? Let's say R12 is like one of our registers, right? Also, I'm confused how there's only 7 registers. The register allocation means, so this is a 7 colorable graph. It's probably less colorable, but that's actually just how many we're using. Because it gets clobbered. Yeah, okay, I'm starting to understand. So effectively, a register could interfere with a web. The web containing the value, that is the div instruction, is what I meant, but that's too much typing. Okay. The web containing the value, that is the div instruction. So for example, web 10, let's just say web 9. Let's imagine web 9 is a div instruction, because R8 is the result of a divide. Right? Let's say R8 is the... we can even look at this. We're going to have to go here. Okay. We have a divide. We're not looking at nested functions is the problem. So if we go to the little example and give us a little boost here, 16/4, where we have a divide, it only shows the main function. Yeah, I fixed it. R10, R4. This is very cool. So divide R10, R4. That doesn't actually get stored into a temporary because we don't need it, I'm presuming. R11 equals copy R4. Okay, so instead of saying R11 equals... Okay. Again, this is after post-processing. I'm starting to get it. The div is originally a 3-address code. That's what I was picturing. It's like, wait, this doesn't make much sense. So basically div would have R11 equals R10, R4, but it would really be R10, R4, R11. This is just how it gets implemented. A equals div BC, yeah. Yeah. But that gets converted to A equals B div AC. Yeah, I get what you're saying. Effectively, because x86-64 clobbers one of its operands, then we have to do this whole thing. In any case, so with this divide in R11, web 4 contains R11, right? So that should technically... Web 4 interferes with nothing. So web 4 isn't the div instruction. Is the div R4? Is that the unique one? I mean, that's a hardware register, like we were talking about, 1 through 7. So R4 being hardware means it'll never show up here. As I said, it's still work in progress, lol. I haven't tested divs yet. What have you tested? What can I see work in a way where the web has, where the adjacency matrix is comes into play? And also effectively, how is this used? So given this, you can check any 2 registers. So any 2 web or register can be compared. Greatest common denominator should work, I think. That's what this is. We're looking at that. There's that, I had to add a div for it to be there. So it says, I have my own test file that I use. I'll send it to you if you're interested. I'm okay. I'm just wondering, this is greatest common denominator example. You know what I mean? And I had to add the div of 16/4 for this to show up. I'm presuming you have some extra debug output that is not pushed. So it says, ah, yeah, right. So web 5 and web 8 interfere because 5 has R10 and 8 has R1 and R9. Shouldn't they only interfere if they are used within each other? These different namings? No, 1 through 7. If you want to see the IR for the other functions, you can do that very easily by changing a line in ra.c. Again, I can't wait till these files are renamed. It's bothering me so much. It's not raw.c, it's register allocation. Because my brain just reads what's in front of it. I'm too stupid. Why is it complaining? It's not undeclared. You're a liar. It's literally included in ir.h. Shut up. With codegen dump ir. Did that happen? I think that happened. It happened. Okay. Nice. It only does the webs and the matrix for the main function. So you told me to do this for no reason? Lamau. You can see the IR now. I could see the IR of a div before. No, I'm just messing with you. It doesn't change anything though. It's literally all the same. And also all these are 0. They're not supposed to be, I'm guaranteed. Guaranteed. I don't think it changed much at all. Sir Aid says that's why, yeah. That's why. Lamau. It's a work in progress. Ooh, 2 of the same. Not what I meant to do. So effectively, it's not clear why these interfere either. R1, R9. Web 8 interferes with every other web. Nope, just 4, 5, and 7. So 4 and 8 don't share any apparent data. I apparently forgot to set them in codegen dump ir lol. It's true. So 14, 13, so why would web 8 interfere with web 4? Again, this is just me figuring out if this is correct or a bug. Interfere. We show the calculation for register web, assuming that there are 3 registers. Given a pair A, B, both operands are registers, or both operands are web, swap A and B if A is less than B. The greater is placed first. If one operand is a register and the other is a web, the web is placed first. This is because webs are placed after registers in the matrix. Totally valid. Add the number of registers to each element of the pair that is a web. So basically skip all the register indexes and start at web indexes. Subtract 1 from each element of the pair. We do this because registers start at 1, but the matrix starts at 0. Valid. So there's entire rows here that aren't shown. Subtract 1 from the first element of the pair. We do this because the first row of the matrix is missing exactly. Because there's no reason to ever check if a web or register interferes with itself. Yeah, so effectively this dot, 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 dot line of ones isn't really helpful. It's always not always, it's also not always ones, but W5 to W5, as you can see, will never interfere with itself. I get it. I'm starting to get it. And if you check the matrix above, you'll see that 3.2 is indeed the index for register web 1. Reg 3 web 2. You're starting at 0, aren't you? 0, 1, 2, 3. See, if that's 3, then this would be 1, 2, which would be here, which would be R3 and R3. But presumably, you're saying the first one is missing? 3.2 is row column. Row column. Isn't that what we're doing? 1, 2, 3 row. 1, 2 column. Where is it? There's nothing here. So row 4, column 3. What? 1, 2, 3, 4, 1, 2, 3. That's here, which is web 1, web 1. Am I counting wrong? It starts in the top left. You can't, if you're saying you start at the bottom left, that's horrid. If you're saying 1, 2, 3, 4. Rows are horizontal. So you're not saying columns are vertical. You're saying it refers to the row, not it actually is. Okay. Okay. Columns are vertical. So when I see the 3.2 is row column, I was like, oh, so 3 refers to like where within the row we are, right? That's what my brain went to. You're saying it goes the other way. Row 4, column 3. Why would you go down and over? That's never how math works. It's okay. 1, 2, 3, 4. Web 1 and web 2. So this would be 1, 2, 3, 1, 2. So effectively, like a C2D array, row first, then column. That's horrid. Why? It's fine. It's fine. So even if you're saying 3.2 is row call, so is this column 1 or row 1? Is this row 1? Or is this row 0? Is this row 2? Because we skipped 1 and it starts at 1? Because R1 should be a row here. The first row of the matrix is row 0. Okay. 3, 0, 1, 2. Now it's starting to make sense. 0, 1, 2, 3, 0, 1, 2. Web 2, register 3. That is now making sense. Sir Aid says, like a 2D array in C, once again. I don't know why you would choose that as how to indices, make it the index of something, right? I understand that's probably what we need. It's just that it breaks my brain. Because how much in school was it beaten into you that it's domain then range, right? Sir Aid says, I also had trouble with this at first. Matrices are also typically written row first, then column. It's domain then range. It goes X then Y. I hate, like, that was beaten into me in school. It's like, it is always domain range. A coordinate pair will always be domain range. And then it's like, oh yeah, but except for all these entire sections of math. Arusius says, school bad. Sorade says, yeah, now matrices are row first. I think that's stupid. It's just dumb. How about we do things backwards, but only for certain things? It's like, yeah, that'll make it simpler. Sometimes it seems like mathematicians just specifically hate both themselves and everybody. What is RR? So RR, effectively, these are just different implementations for what our different things are. So if we have web to web, register to web, web to register, or register to register. So these are our 4 little cases. Okie doke, okie doke. This is starting to make a ton of sense. So to build this matrix, what are we doing? Set data to 0. This means it must be a square. So there only are rows. There's no column, in which case we should call it size. Also the number of columns. Just call this like a dimension or size. I don't know. It's a square, yes. Alrighty. It's always a square. Sounds good to me. Registers always interfere with each other. What? So you set R2 to R3 here, but you don't set R3 to R2. Is that on purpose? This isn't directed, is it? Dimension is better. I just couldn't think of a name, lol. That's fair. So I've noticed like R2, R3 is interferes, but R3, R2 does not interfere. Is that on purpose, or is that just debug output? Do all these zeros just need not be here? And these should not be zeros. It should be a copy of this bottom half. I mean, these should all be zeros. It's what's called a lower triangular matrix. So you're just printing out all of it. But again, the top left triangle is not in use. That's the right side, but I trust you. So effectively, all of the registers are done here. Yeah, we definitely don't want to print out all these zeros if they're just unused. I know that's complicated. We'll get there. Let's debug output. Sarade says that's true. Yeah, it's just, it confuses things. Like, oh, R3 to R2 isn't, but R2 to R3 is. It's like, depending on how you look at it, you'll get different values, which is horrible. So all the registers always interfere with each other. Okay. Is that a function pointer? What is this? Yes. I didn't add the unused zeros in the comments. I don't know why I added them in the debug output, lol. That's a function pointer. That's a funky function pointer syntax. It's like normal. What'd you do? Check raw.h for more information. Okie doke, okie doke. Add edges between webs and registers that interfere. So you would think that register R1 interferes with web 8. But it does not, because they're the same, right? So R1, there's effectively 8 hardware registers here. That's what we're saying, that always interfere with each other. So these hardware registers are always their own temporary values. So this is starting to make sense. So each register can't be the same register in a hardware implementation. Fun fact, you don't need the star if the function pointer is used in the declaration of a function argument. Oh god. Arusia says raw.h, Rasputin. Rasputin. Lamau. Yeah, that's terrible. Gotta love C. So each of the hardware registers, yeah, there's 7, because R0 is whatever, invalid. But yes, so basically each of these are hardware registers. And if this hardware register is used in a web, that means they don't interfere. But if it's not used in a web, see, it seems like these registers never actually interfere with webs. Is this square always 0? Right? This square here. What is it? I have to do... Is that square there always 0? I think that'll always be 0, right? Unless hardware registers ever interfere with a web. But I don't think that's possible for a hardware register to interfere with a web. They interfere with webs if you have calls or a div or shift instruction. So they only interfere because those instructions clobber registers. That's exactly what I was just about to bring up. So they only interfere on destructive assembly instructions. Okay. So effectively, because when we look at code.s, if we actually were to write some stuff here, right? Move the stack pointer into the base pointer and stuff like that. There's probably some more stuff I'm forgetting, but if we did a div, the answer is always in racks. So if we had like RCX as our register, then because it's always in racks, that means that effectively R1 or whatever racks maps to, right? Whatever racks maps to would interfere with the web of whatever this is, which is a value. So the div, for example, R4 here. Okay, here's a great example. R4 should interfere with the R11 type of thing. A web with R11 in it. So web 4 and R4, shouldn't they technically be bopped? I'm pretty sure there should be a 1 there. Unless I'm mixing that up and getting it backwards. Because R11 needs R4. So it says more or less that, yeah. Again, this is still work in progress. Oh yeah, I'm not saying like this is a problem. I'm just trying to figure out how this is working. All of this register allocation stuff is fairly complicated. It's very complicated. I wouldn't worry about having little bugs like this. We just need to identify, or for me, I need to identify where the bugs are so I can go, oh, this is how it should be. And then I can start to actually look at the code and go, oh, this might be wrong, or stuff like that. Because I need to actually have a mental model of how this works. So hardware register R4 should care about R11. I'm sometimes not exactly sure either if the behavior is correct or not. That's not good. That just means we need to talk about it more, because I'm sure we'll be able to catch each other's weaknesses. Add edges between webs that interfere. Platform interfere P of V and I. What is V and I? Why do you use these names? Why? What is V? Where's V even come from? It's in this for loop, and it's a pointer. Okay, so this is a pointer to a value of W. God damn it. What is W? No, it's another web. So it's a web within this given web. So it's probably a linked list of webs. This linked list of webs. And we want to add edges, size VI. So this is index. Okay, I'm starting to get this now. Index. Web is a linked list of webs. Yes. Okay. Starting to make sense. So for every web in the linked list, blah. For every value in each of the webs, blah. For each register in the adjacency matrix, so for all of our hardware registers, if platform interfere P, blah interferes with blah. So that's this. That's this here. See, it's fairly suspicious that we never see this. So platform interfere P is definitely where the problem is. And we get a value. And what? I. What is I? I. I++. Register, hardware register index. Okay. I is the physical register. Yep, that's starting to make sense. So it's an index, it's like the actual physical register enum. So we'll get 1 through 7 of I. Well, 0 through 6, because this is actually 7, but it doesn't matter. So where is platform interfere P? It's past, so I'm assuming in x86 arch. Here we have platform interfere. It is not. Okay, interesting. In raw.h explains it. Okay. Whoops, we'll do that. Platform interfere P is a callback that when passed a value pointer in a register number should return 1 or 0 depending on whether that register is clobbered by the instruction that computes the value or not, respectively. All right. It's just called interfere. Okay, nice. Interfere P. That's fair. Oh. Sorry. This is starting to make sense now, why it's a little complicated. So we're checking, does a given register interfere just based on the semantics of the backend? Does it interfere with the left-hand side value calculation? Value, as we previously discussed, is basically just an IR instruction, and that may be a better name for it. Because it's an IR instruction type, an IR instruction value, and then an IR instruction bleh. Yeah, it's basically a tagged union. And this tagged union is, for some reason, called value, but it doesn't need to be. It could be called IR instruction. So if IR instruction type is a div, then RDX. If it's mod, then rax. These are backwards on purpose, okay? Because div clobbers RDX, but it also clobbers rax. So if rax is here, shouldn't div do both RDX and rax? I could be wrong. Could be wrong. So should this be like or register equals register rax? This could very much break many a thing. Rax is actually used, so that can just be in the web of the value. Okay. Okay. RDX is not used, it's just clobbered. So effectively, so we're basically just saying if the answer is unused, so what is clobbered? So what is IR instruction div one address? If value register equals rax, return equals RDX. Again, I'm not sure this is right the way it is right now. Yeah, this I'm assuming this would be, why do we have different IR instructions for different divides? Not sure that's ideal. Maybe needed. I don't know. So why do we have one address? Used by the backend only. Should these be in a separate enum? I would presume so. Why? This is what div gets lowered to. These should most definitely be in a separate enum, because whenever we handle all of the instructions, we're not going to be handling all of these. Copy register, spill, unspill. And add gets lowered to add to address, and so on. What does address mean? Because it's not always you can't add between two addresses in backends. Like in assembly, you can't add address to address. You need a register or a literal or something like that. So what does two address actually mean, or one address? Two address just means two operands. Oh, okay. So div with one address means the answer will be in racks. Uh-huh. Uh-huh. So div with one operand, like we were just discussing, stores, okay, so clobbers RDX without using it. And this uses racks as return register. So with one address, if a given register interferes with it, would be, so RDX interferes every time. Is this handling modulo? This might be handling modulo for one address as well. So does modulo get lowered to div1 address? Does shift left and shift right change RCX? I didn't know that. Both div and get, okay, both div and mod get lowered, but the only way we're able to figure out how, okay, yeah, I'm getting it. Sarade says also be right back. No problem. I'm probably gonna have to stop streaming soon, so you may not be right back because I may be gone. But thank you for hanging out, Sarade, so much. I gotta eat lunch soon, otherwise I'm not gonna be able to eat today. Which probably isn't a good move on my part as far as health goes. You know, just don't eat. So when we div one address, we're basically saying if our return value is racks, then we're assuming this is a div. But if our return value is not racks, then it's RDX. So then racks is interfered with. This all looks right, which makes me worried because it appeared that this is where everything went wrong. So with this interference graph, if they interfere, why does that matter? What is that then used for? Allocation. So in allocation, we build our webs, we build our matrix, and then we print it out. How is this adjacency matrix actually used? Has it already figured out what registers can be used for what? Is there more work to do by the backend? There's no more register allocate. It's been changed. And it currently works how? IR instruction type equivalent. So it says if these are equivalent, okay, return the equivalent, the lower level equivalent. That makes sense. That all makes sense. These should definitely not be here. These should be in an enum that is specific to x86 64. because then it wouldn't be equivalent. That's it wouldn't be equivalent. We would just translate not into a different IR instruction type, but just into a different value here, different enum. Create copy. Copy of what? Of a value? Probably. And it doesn't use context. Maybe it's never used. Insert after. Value into insert. Next equals next. If next, save it. Nice. Very good. Insert before. So we no longer have emit value, or at least it's commented out for some reason. And oop, here we go. So we still have emit instruction, femit x86-64, but we no longer have. So when we emit, what do we do? Emit the main function. We'll emit all the functions. And all the functions it's all been commented out. Lol. So the idea would be that if it wasn't commented out, what would happen? Why are we not trying anything? So yes, we have like div mod do thing. But this is still using a register pool type of thing, which is probably no longer going to work, is what I would guess. But we're still going to have to use it somehow, are we not? Siraid says, all right, back. What's up? How's it going? These heap allocations are jank. It's fine. It's fine. So we were just kind of considering why no code is being emitted, and it seems like the current issue is that register allocation, there's no actual register allocate function, right? Or deallocate. Because it now works entirely differently. There's no longer going to be a register pool in this way, right? We're going to have to like map. Sir Aid says exactly. Okay. And the current issue is we're going to have to map this adjacency matrix into existing. No more manual register allocation. Well, you say that, we still have to do it. I would say no more explicit register allocation. You don't have to allocate and deallocate explicitly. It's all garbage collected, effectively. You could call it automatic, that's fair. So the problem seems to be that currently registers and webs just don't interfere. Something like that, yeah. Okay, so currently, how would we actually allocate a register given this adjacency thing? Everything's register is already predetermined, right? So we're going to have to map a web into a register. Is that making any sense? So every single one of these webs has to have its own register. The register allocation takes the interference graph and colors it. Yes. Yeah, I'm getting you there. So effectively, so what are the cases in which, like, how is this adjacency used? we effectively have to say R1 through R7 can be in use or not. Is that still a thing? I don't think that's still a thing. We're going to use webs because each value has its own web, right? Or webs have lists of values, and I think values point back at their web. We go back to ra.c. No, values have register, values have values. So webs refer entirely to values. Values do not refer to webs. Thought we accessed webs in that way, but I may be wrong. For every value, there is a value web. Okay. So it says each vertex in the graph is a web, and edges exist between webs that interfere. Each vertex in the graph is a web, sort of. They're also registers. Edges exist between webs that interfere, which is what this designates, this one. It designates an edge. We're congruent. Graph coloring assigns a color to every vertex such that no two adjacent vertices have the same color register. So each of the vertices is a web. 1, 2, 3, 4, each of these. So these are all vertices. No two webs that interfere, right, are assigned the same register. So we have to go through this matrix here. This isn't really important, is what I'm getting. I could be very wrong, but it looks like we're just looking at web interference. Again, web to register interference, very important, probably matters. We'll get there. This is equivalent, okay, this is equivalent to assigning a register to every web such that no two webs that interfere are assigned the same register, and every value in a web is assigned the same register. Beautiful. So effectively, web 1 to web 1, so that doesn't matter. So we're starting here with this little triangle. Yeah, I'll keep that little rectangle. Okay. The actual register allocation will use a different representation of the interference graph, but that representation is generated from the adjacency matrix. That's what I was just imagining. I'm like, okay, so we're going to have a graph with all of these as nodes. And they're going to be, they're going to have edges between them wherever these are 1. That's starting to make sense. So if we wanted to like draw this, we could, but I don't really want to draw this right now. W2 interferes with W1. So 14 and 13 temporary values cannot be the same register. Right? So web 1, we can just assign R1 because they don't interfere. Web 2, we can just assign R2, and we can't assign it to R1 because it interferes with web 1, which has already been assigned to R1. So web 2 gets R2. Web 3 interferes with web 1 and web 2, so it cannot have the same registers. So it must go in R3. Web 4, however, I'm not sure if this is correct again, does not interfere with anything, which is a little scary. Feels like it should interfere with something. Web 4 doesn't interfere with anything, R11. So what that means is we can store it, every value in a web is assigned the same register. Because it doesn't interfere with anything, does this mean we can assign it anywhere? So web 4 just gets R1, because it doesn't interfere with web 1. Web 1 was assigned to R1, so let's just go with that. But so different webs may be assigned the same register, apparently. Or I'm doing this very wrong. W5 interferes with W4. So web 5, R10, interferes with web 4, R11, which means that we can't assign it the same register. So this would be R2. This is also not the final adjacency matrix. True, I'm just going through, it's still missing register coalescing. True. I'm basically just going through and figuring out how our register allocation would work by hand. We basically go through a web and then look for, effectively, okay. We go through a web, and then if it interferes with no registers, basically find the first register it does not interfere with. Find the first web, find all of the webs it doesn't interfere with, or does interfere with, and skip those. Yep. Yeah. So we're effectively going to say, because if W3 didn't interfere with W1, we could store them in the same register, which means we could use R1 again. So basically, we're going to have like an index into our registers, and this is just going to be which one we allocate, and that index is going to be calculated based on the interfered web. So W3, for example, would say web 1 and web 2 is interfered, so then we'd say, okay, web 2, which register was it assigned? We can't use that. Which register was it assigned? We can't use that. So for every web that interferes with a given web, so for W1 and W2 of W3, they both interfere, add to this index, and that'll get you the third one, R3. Kind of makes sense. So if you start with 1 and then add 1, you get to 3, R3, and that's one we could use. But then in W4, you can just go to W1 and say, well, there are no webs it interferes with, so all we have to do is use the index. W5, it interferes with 1, but it interferes with W4. See, this is where it gets complicated. So W4, well, the thing is, it was stored in R1. So yeah, there's one interference of W5, and we can just use R2. W6 has no interferences, so we can go back to 1. W7 has many interferences with 1, 2, 3, 4, 5, and 6. All of these webs. So I noticed there's no web 8 here. It's interesting that we have R1 through W7 and R2 through W8. Oh. Effectively, it is more efficient to store it this way. I get what you're doing. You're basically squishing one out that way and one out that way. It's pretty cool. Okay, but for W5, there's only one. We can use R2. W6, nothing. We can use R1. W7 has like all of the things, but we wouldn't have to use all of the things. So 1, 2, 3, 4, 5, 6, 7. So we could use our last register here, but we don't actually need to, it doesn't seem like. Well, maybe we do need to based on how Web 7 works. R16, R15, and R1. Yeah, so R16 and R15 can be the same register, and R1 can be the same register because it's copied. So you see that this little ditty, while there are a lot of temporary virtual registers used, R1, R15, and R16 are actually the same hardware register because Web 7 can just be stored in R7. So this would be R7 equals R7, which would be optimized out but via peephole optimization in the backend, so then nothing. And then this would also be R7 equals copy of R7, which we may implement in the backend, but I don't think we're going to. It'll also be peephole optimized out. Beautiful. It's still missing register coalescing. Not sure exactly what that means, but it is interesting. W8 interferes with W4, W5, and W7. See, W4 was stored in here, 5 was stored in here, and 7 stored in 7. So if we just did 1, 2, 3, could We store it in R4. W8 is R1 and R9. R9 is an immediate. R1 equals copy R9. So that's saying rax is equal to a copy of R9 of 16 because it's div. We have to generate that explicitly. Okay. So it seems like to know which register a web will be assigned to is going to be the complicated part. That's the actual register allocation part. And that's the difficult part, ironically. So all of these webs, if they don't interfere, could be assigned to the same thing. Suraid says essentially, yeah. So web 1 and web 2 and web 3 and web 4 and web 5 and web 6 and web 7. See, these zeros make it very misleading. Because web 1 doesn't actually have any entries. This doesn't matter. So web 2, the fact that it interferes with web 1 means that they can't be stored in the same register. Okay. I think I know how to do it. Suraid says yes. So web 1, the first web will just pick the first register, or any register, right? R14 will just say it goes in R1, sure, because it doesn't interfere. It's fine. Everything's good. So R1 gets W1, or W1 gets R1, however you want to think about that. I'm going to make this bigger. So let's say W1 gets R1 because they don't interfere. W2 now has a list of registers that it cannot be in all of the webs that it interferes with. But a web can only interfere with a web. Yeah, so a web can't interfere with a later web. That doesn't make any sense, right? So I guess web 7 and web 1 interfere. So web 1, this again, the zeros being so misleading that web 1 and web 7 are fine. So web 7 and web 1, see again, I just tried to go there again and it didn't work. Web 7 and web 1 do interfere. So we get a list of registers that it can't be, because assumedly all of these webs have had registers allocated to them already, even if they're the same. So for example, web 1 gets R1, web 2 says I can't get R1, give me a next one, it'll get R2, right? So web 1 register 1, web 2 register 2. Web 3 says I can't be R1, I can't be R2, I'm going to be R3. Okay. So now we have web 1 in register 1, web 2 in register 2, and web 3 in register 3. And they don't interfere, so all of that should be good. Then we get to web 4. Web 4 interferes with W5, W7, and W8. See, that interferes with a later one. So we only have to check webs that we've already allocated registers to, question mark? Is that wrong? Can an basically, so web 4, it's saying, hey, whatever web 4 is just has no problems being anything. Well, it says I can't be 5, 7, or 8. What is 5, 7, or 8? 5 is R10. So we need R10 to get R11. That makes sense. 7 is 16, 15, and 1. And we can't do that because reasons. So it seems like web 4 and 7 should not interfere. I could be very wrong. Because they don't contain the same values. Maybe they interfere for a different reason that I'm not thinking about. That is the case if any of the values in either web is live at the definition point of any of the values in the other web. So effectively, the liveness of R11 has been assigned to, and it's never used, so it's alive throughout the entire program, even though this is an unused expression. That's probably what our main problem is right now, is that unused values are not being deallocated, or said to be dead the whole program. Because R11 should be dead the whole time. But currently it's alive the whole time, which is probably creating a whole bunch of issues with web interference. Or it's correct and I'm incorrect, but I'm pretty sure that's invalid. Just because we're not checking for the case where R11 never gets used. Suraid says that may be a bug, but the thing is unused values should be removed before register allocation anyway, so, well, they should be, but they aren't. So you're gonna have to write something in register allocation that removes them, or before that. So maybe in code gen, we have to do like a remove dead code pass, right? After we make our IR, we have to figure out, is R11 never used? Right? And then with that unused data, I mean, really, we should just create a level on like the an entire program error or warning, like, hey, this is unused. Are you sure you even wanted to do this? But effectively, before I start worrying about complicated bugs, I'll finish the register allocation and then we'll see. That's perfect. I think that's a perfect idea. I would love to see it finished. Even if it doesn't work, I don't care. I want to start fixing bugs in it and like figuring out how it works or is working. So effectively, this isn't our final adjacency matrix, but it seems like from this, we can start to piece together what registers to use. So register allocation will effectively be going through every single web and figuring out what other webs it points to. And if it points to another web, that's at least how many registers we need. So for this program, we need 1, 2, 3, 4, 5, 6. 6 registers. Might take a day or two off though, otherwise it'll start haunting me in my dreams soon, lol. Lol, W7, W8. So effectively, because any graph with is k colorable given each vertex has k edges, we're going to create our interference graph from this adjacency matrix. And basically, each of these ones will refer to an edge between W7 and W1, W7, W2. So the fact that each of these ones, this is why I was thinking that counting each of the ones for each web would work, for giving us which register, by the way. It will work, because that's literally graph coloring. So the fact that this has 6 ones here means that we need 6 registers to represent a program with this web inside of it. And then we just have to less than k edges, but yes. Okay, so we'll have 7 registers, is what you're saying. Hence 7 registers. So we'll have 7 registers given this program. Because 6 plus 1, or 7 minus 1. However you want to think about it. Starting to make sense. I wish I could start working on the code. I'm starting to understand it. We should definitely have webs interfere with registers, but they are not. So platform interfere B. Again, not named that. So for value in web, so which value in which web were we thinking about? Whatchamacallit. So R10, R11. R11 is a copy. And there's no actual, so R11 should hopefully equal div R10, R4 when it's not lowered or whatever Suraid has been talking about. So R11 equals div R10, R4. That means that the web of R11, web 4, should contain interference with what? So in x86-64, R11 has to be racks. So R11 must interfere with R1. I suppose an easy way to check would be to see if value uses is null, and if so, the value is unused and doesn't interfere with anything. That's a great idea. That is a great idea. Okay. Yeah. Do that, actually. Yeah, that. You're really smart, Suraid. That's exactly. So edges between webs are completely fine. We can figure out if webs interfere, but this isn't really working. So for every register, so this should be for every register, if platform interfere p with that register. So platform interfere p, we're switching, what is register? What is reg rdx, right? Arch. Okay, it's not needed there. Reg rip. Where is this defined? Define register enum. I have a feeling. For all x86-64 registers, define register enum, which says name ... reg ## name, comma. Name ... so we'll stringize name. So that would become reg _ racks. So racks, rbx, cx, dx, 8, 9, 10, 11. So up until 10. So effectively num registers would be register count, right? Effect is assumedly. So we're going to go through every single register. Suraid says, I'll write that down. That's a great idea. King Bun says, Suraid, what do you do for a living? Suraid built Stuxnet? Confirmed? Lamau. So webs and registers not working. Undefined reference to print F. Lamau. Okay, so all we have to say is, oh boy, web blah does not interfere with register blah platform. That doesn't seem right. Oh, it does. It does seem right. So Web1 R14 does not interfere with register 14. The reason we're saying register 14 here, again, we really should have registered a name something here, right? So we have this register. So our value register, what is our value? Our value is within our web. So within web, register 14 would be a virtual register. That's what I was just picturing. Yeah, it's our value register. I don't think... So basically, when we're looping over all of our registers, our number of registers, to build the adjacency matrix, where does this number come from? Because we set it to 0 in the data, but what does M actually get passed as? Where is this called from? Build adjacency matrix. Okay, and it's passed matrix, which says numregs equals numregs. Well, that's helpful. And allocate registers is called with a number of registers. So how many registers would we like to allocate? Okay. For register coalescing, I've already added, or I'm going to add, I don't remember, a physical register P function that checks if a register is a physical register. So why do physical and virtual registers bleed into this at all? I'm confused why there's a concept of physical and virtual registers. Is it just to handle clobbering? Right now it's the number of scratch registers. Okay, so this is number of scratch registers. Why is that here? Is this ever used? It's unused. Okay. Oh, here it is. It's used here. Egglet does not like it being used here. Just my language server won't highlight it. It's just for printing. Eventually all the virtual registers are going to be just 0, which stands for no register. All right. Print web. So this register bleh seems like it should be a hardware register because it's using the hardware register enum. Right? So it's not, if you only pass in the number of scratch registers, it's not going to work because there's more registers than that. And the first 7 aren't the scratch registers. Nah, mean. So this doesn't calculate the enum, which is what we're checking for in the arch in interfere P, is the issue. See this right here. RDX is never being reached, or it may never be reached if it's later in the thing. So aren't we comparing between like hardware registers and virtual registers then? This is confusing. Sir Aid says, ah, I see, that makes sense. Yeah, I'm getting a little confused because we're supposed to be comparing this, but then we're comparing its value with... It's just indices right now. There's a comment in rod.h that addresses that. Rod.h. For this assigns physical register between 1 and numreg. If the result register of an instruction is already set to a value between 1 and numreg, then the register allocator will respect that and try its best to work with that restriction. I'm not seeing it. So, it seems like these won't match up in comparisons, because register here is being passed as number of scratch registers. So the fact that we pass in like 0 first means we will check racks. But we're checking against what? Our value? So if our value type is a div, so why doesn't that happen? Right? It seems like if value type is a div, this should be important. It says web 7, 16, and 15. So web 7. Web 7. You can see 16, 15. And it says does not interfere. Because these temporary registers are temporary. Yeah, this isn't right. What I need to do is put RBP, RSP, and RIP at the end of the enum and then tell it to allocate up to 13 registers. That's what I was thinking. It was looking a little funky. I was like, this should definitely not just always be 0. That's definitely incorrect. And I was like, I know something is happening. But yeah, so it's just the fact that we're comparing virtual to hardware registers, which doesn't really make any sense in a sense. But with number of registers allocated up to 13, what is that going to do? Well, then we loop over all the registers. And we're basically going to say, what? So why do we have register 14? Web 1 does not interfere with register 14. So we're basically checking add edges between webs and virtual registers that interfere, right? But that's not what we want. We want hardware registers. So if we had 13 hardware registers instead of 7, then what would this mean? This would mean that these numbers just start higher. Not sure that would work. Sir Aid says, the code is wrong. It's true. I'm just trying to figure out how it would work if it was right. It should check physical registers. That's what I was... Okay. So this is what's incorrect here because vreg refers to this debug value. But we're actually meant to be checking if this interferes with something else. Yeah, I'm starting to get it. Okay, well, at least we've identified it. That's a big bug. I'm not saying it's a bad thing that we've written this either. And I'm not saying, how could you have written this? It's like, it's very clear that this is all so complicated. Look at how many for loops we have nested here, right? It's not like this is a simple issue. So finding bugs is a positive thing because we know they exist, so it's good we have found one. So the fact that web does not interfere with register. Yeah, I spent a lot of time writing this, even though it's not a lot of code. I can imagine, just conceptually, it is a lot of code. It's like, how does this actually fit together, right? That's the hardest part of all this. It's like, we can traverse trees all day and all night, but figuring out how and when to traverse trees, that's the issue, right? So, what is this? Web interferes with register, blah. What does it mean when a web and a register interferes? What could that be? A web and a register interfere if any of its values clobbers a hardware register. Wait. If a web and a register interfere, that means that web can't be assigned that register. That's the result, but what's the cause? Why couldn't a web be assigned to a register? That's I know I'm kind of I'm kind of asking this backwards. So web 1 can be assigned to any register because it's the first web. Web 2 cannot be assigned a register. I guess it can also be assigned a register 1, unless register, but it interferes with web 1, which has register 1. The cause is usually a physical register being used while the web is live. So the web has a list of uses. Does the web have a list of the uses? A web has a list of values which each have their own list of uses. So we would have to figure out the furthest value use, which would figure out the web's lifetime. Is that even needed? It is needed. Because when we get to web 2, so effectively a register in a web, W4 should care. W4 says R11, and it copies R4. So R4 should be a problem for W4, because we need R4 in order to calculate W4. Well, it doesn't interfere, I guess, because they could just be the same thing, right? So a copy of this R4 means that R11 could just be stored in R4. Copy and phi are exceptions. That's what I was just figuring out. So effectively, R4 and R11. So it's clear to a human that R11 and R4 should just be one thing. But it's not clear to the allocator. So we want them to not interfere, I guess. But web 4, so R11, should care about R1, right? Also, R4 doesn't really make sense. It should be R1 for in racks. And it will be clear to the register allocator after coalescing. That makes a lot of sense. That makes a lot of sense. So web 7 has R1 at the end, right? Yep. So web 7 having racks in it. These webs are being constructed correctly, which I think is beautiful, by the way. We can build the webs, which is impressive enough. So it's easy to tell if values interfere, it's easy to tell if webs interfere, but the hardest part comes from detecting whether webs and registers interfere. Basically, if any value in a web contains a hardware register, so if any value within a web contains one of those funky ones, then all we have to say is yes, right? I. So I is the hardware register. Register is the hardware register based on num_res. So if we get a value of divide, we want to say if I is what? So if I is racks, well, our dx, racks is our quotient. So our modulo or remainder is in rdx. So the fact of a divide instruction interfering, it only interferes with the rdx register. So platform interfere p of v and I. Oh god. So v would be something within a web. So let's think about web 4. And it's saying web 4 does not interfere with register 11. Okay, so if I print this out again, what if I just place that with I? Right? Also does not interfere. I love how you keep switching to the compilation buffer, even though it's open on the right, lol. Well, when I recompile, it's all small. I have to make it big. You're right, though. I don't need to. Okay, so Now we should iterate over all of our things. Six. Interesting. Isn't that interesting? That this web4 does not interfere with any registers 0 through 6. Ain't that just so interesting? So this really isn't even a web interfering, it's a value within web. How do we print a value? Do we ever print a value? I'm gonna try and steal it. Webs. For value count, print RZU. So print the register of each value here. So for every web, for all the values, print out their register. So it seems like printing out value register isn't the worst thing to do. What's the enum value of RDX? It's 4, so that shouldn't be the problem. That's what I was just going over as well. I'm like, wait, RDX should be caught here. Compilation exited abnormally. Oh, we're using I where we shouldn't. W values at I is just V. But V is a pointer. R14 does not interfere with blah, blah, blah. So we should say R11. So we are at R11, the value here. Right? So we'll say, whatever, move this. Blah, 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 blah. Web 11. R4 does not interfere with register 4. So R4 is referring to this value. So interestingly enough, in Web 4, also I got these backwards. That's why. I was like, wait, this isn't right. Should be a little better. Web 14, I don't think that's right. Well, you're correct. It was just backwards. Okay, this makes more sense. Web 4, R11. R11 does not interfere with anything. So what is R11? What type does it have? R11 is this thing. So this is this is just the number 11. So we want to access its type. Value type. I don't even know. Probably an integer. Type. Hopefully it's just called type. Okay. So Web 4 has a value instruction type of 26. So we need to figure out IR instructions. 26. Copy register. Copy register. So which one has the divide, if any? Or do none? So this switching to copy means everything kind of breaks it, because divide is no longer in something. So this lowering is actually breaking it, it seems like. Because we need the instruction type to be divide. Otherwise we just lose it. Because there's no actual value here that it ever has divide. Nah, I I haven't implemented copy register yet. Still, we lose the clobbering data of div by doing this little lowering here. I don't know where this lowering happens either. You keep saying lowering. Not seen any code that lowers. Right? So x86 64 dump. See, we just dump IR, so that should be in. So is it when we dump it that it gets lowered? What's the idea? Check cogen in x86. Sir Aid says, it's a janky instruction to begin with. I think a better way of handling this would be to just add a register node. Check cogen function in x86 or something like that. Emit function. Okay. We're here. Emit function. What's the idea? Why am I looking here? I'm looking for lowering. Copy the return value into racks. That's not why it's happening here. That's why it's happening here. Convert to to address. That's the lowering. Oh, bless. So why does this need to happen? Is it just because this is only for things? Okay, so convert to address. I don't like address, but it's okay. So convert to operand, because it doesn't have 3 operands. Again, it only has 2 operands anyway here, which is why I don't like it. That's why it says to address, because it's saying this third address isn't here. I get it. I get it. It's just, it's a confusing name for me. So for every value in every block in the function, when it's an add, when it's a shift left, shift right, when it's a mod or a div, create, copy, blah, 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 we have to set the result register here, right? Which it's apparently being set. If you have a equals b plus c, the register allocator doesn't realize that actually a is just b and also b is clobbered. If you have a equals b plus c, the RA doesn't realize that actually. Yeah, it doesn't allocate a new register. I know what you mean. That's why you have to convert that to a equals b, add ac. Percentage a equals operator bc. Percentage a equals copy b, operator ac. A is equal to b, then add into a, c. So this is like an Intel syntax. It's a little confusing right to left, but especially with the percentage signs. But I'm starting to get you. So why does this copy have to happen at all if they're in the same register? Is this just for this? So why can't we just use register B, right? Because then B gets clobbered? But if they're the same thing, yeah. That's how it worked anyway before, with our result register being the same as the left-hand side. Sir Aid says that's not how it works. Okay. So you can't just clobber B because B might be used later on. You have to somehow generate a new value. That's confusing. So every operand to every math problem ever stays in a register forever? I'm confused. Right? Like we can't just keep, like if we did 1 plus 1 plus 1 plus 1 plus 1, we can't just keep copying ones into new registers, right? We should use the result register of the last one as the operand of the left-hand side. And we should clobber. When would math ever not clobber? I'll have to explain this in detail in a LaTeX document once it's done. It just doesn't make sense to me at all. You have binary operators. They're never going to have their values somehow used later. Right? So if you have like a plus b equal, I don't know, plus a plus b. We don't want to save a here when we do this because we need this. You know what I mean? How would that ever actually happen? The values might be reused as a result of optimizations. Right. But never in actual regular code. So all this is doing is making a copy where it doesn't have to happen most of the time, right? It seems like this should be under a very strict, like, if this happens, then we should probably do it. In general, you cannot ever clobber a value in static single assignment form. So if that's the invariant of SSA. I hate I hate when people use fancy words for no reason. That's the basis of SSA. That's like the one truth of single static assignment, is that each thing should be alive forever. So assuming each thing is alive forever, then what does that mean? So that means, like, if we had 1 + 1 + 2, then 1 would be stored in A, 1 would be stored in B, 2 would be stored in C, and then 1 + 1 would be stored in D, and then, is that correct? This is kind of insane. Sir Aid says exactly. Okay, so assuming that this isn't insane, even though it seems like it, it seems like right, copy racks, and then insert the racks copy before the div. And copy register. What's the difference between copy and copy register? It seems like we have so many instructions, extraneous instructions, that we don't need. King Bun says very functional, XD. Just, yeah. The register allocator and the whole backend operate under the assumption that once a value has been computed, it will never change. Right. But that's not how the real world works. The registers will change. That's why I'm thinking, like, this doesn't work. If you clobber or change a value, I have no idea what'll happen. I'd call that undefined behavior. I think you're getting too far ahead of yourself, bud. I'm not talking about temporary values clobbering each other. I'm talking about the actual clobbering of the low level. Like, why do we actually need to allocate a new register when we don't have to? Because it seems like, why would we have to copy from this thing to this hardware register to this temporary when we could just use this hardware register as the result? Like R4 equals div R10 R4. Nah, mean. What? Again, copy register is jank. I might find a way to yeet it. Lol. Yeah, it doesn't seem like... I'm just confused as to why it would be needed when we could just use the same register. So in our single static assignment, it makes sense that R11 is its own thing. I totally understand that. Suraid says, I'll explain it in the docs. Doing so is a rather lengthy explanation, and a Twitch chat is not the best way of formatting that, lol. It's true. It's true. Any way you would like to communicate? So R11 in the SSA makes sense because it's a new value, but why is it just copying R4? You know what I mean? Why don't we just have it be R11 equals div R10 R4? And why is... I mean, and I guess R1 technically should be used as something here. Because R10 is 4. What is R4? R4 isn't even used here. There's nothing here referring to R4. That's just RDX. So why is RDX happening? Like all this stuff with RDX happening for no reason, right? It doesn't make a lot of sense. Doesn't make a lot of sense. Because what we really want to do is divide R9 by R10. So we move R9 into racks. And then we divide by R10. And then R4 is just here. Div. Racks copy. Copy into racks from our left-hand side. Yes. Div. Creates copy of right-hand side. What? So our right-hand side should be R10. No? So then type goes to div1 address. Value right-hand side. Interesting. Div. Okay, I'm gonna have to go very soon. Sir Aid, I will love to see the register allocator just generating code. I don't even care if the code, like, it just every register it allocates is racks. I just want to see it working by tomorrow. Then at least I'll be able to make more content. The reason why it's doing something that seems weird to you is because it's incomplete, because register copy instruction is jank, because the lowering code likely has bugs, because the interference graph likely isn't correct, and because these are generally fairly complex concepts that I can't exactly explain in detail right here and now. I'm not wondering why it doesn't feel right. I may be wondering aloud why it doesn't feel right. Also, Emacs is unhappy with ClangD. First time chat from a viewer, Rust compiler, are you gonna push newest code to GitHub? This already is pushed to GitHub. It's been pulled from GitHub, actually, from Sir Aid's fork, working on the IR. Also, I'm not sure I'll be done tomorrow. Like I said, I don't care if it's done, even if it allocates racks to every single register. I just want to see code. I want to see code being output again, because I miss it. And it's driving me crazy. But no, if it's not done by tomorrow, don't worry about it. It's not like a big deal. I'll just have to figure out. I really don't want to write tests in Algol yet, especially when we don't have anything done. I want to start getting things done. So I want to look for div. Cogen divide. Okay. Where is cogen divide? How do you do this? So it's probably in cogen IR. In ir.c, bless. Sum is a little bit of a weird word, but okay. You can the copy and paste is strong with this one. First time chat from a viewer, Diogenic. Are you also coding the AST yourself or using some library? There are no third-party libraries allowed in this program. Saraid says classic copy-paste programming, Lamal. It's true. This should not be sum. This should be quotient. Rust compiler says you have newest code, but GitHub is behind. I mean, you're incorrect. I told you before. This is Sir Aid's fork. It's completely on GitHub. It's literally right here. So I don't care if you keep telling me I'm wrong. I'm right. So when we cogen a divide, we basically just say insert a value, which is a quotient of a divide. So where does this lowering happen? Because this lowering doesn't happen on the x86-64 level. It changes into a div1 address. I'm so confused where this actually happens. Serraid says it does. It does. Okay, I'm incorrect. Where does it happen? This is a div1 address, so where does our div2 address happen? Rust compiler says, you were right, thanks. I clicked on repo and description. Yeah, try using your ears when I talk to you to answer your question. Not trying to be mean, but come on, you're like, are you going to push it to GitHub? I'm like, no, it's already pushed. Here's where it is. And then you're like, oh, but it's not there. It's like, well, you didn't look where I told you to look. There is no div2 address. I think just storing a register in the div for some reason. Not exactly sure anymore. I'm just, what do you, what? That's not what I'm curious about. I don't care that there's a register stored here. It makes sense. It has to return a register or something. Something has to happen. It seems like it is not working at all. Value type. What is value? Well, value type is already, for sure, you switched on it and got to IR instruction div. I'm pretty sure it's a div. You know what I mean? Pretty sure it's a div. It is not working at all. That's why the interference graph is wrong. That's what I was picturing as well. I'm like, this is the wrong conversion. No, it could also be a mod because fall through. Okay, it could be mod. You're correct. You're correct. I missed that. There's too much. So if it's mod, then this would be RDX. Why would right-hand side be RDX? These seem backwards. Right? So our right-hand side, there should be no right-hand side. Correct? It's a 1 address. I'm not certain. I'm sure it'll clean up by tomorrow or by in a few days, whenever you can work on it. But it's very interesting. So split into compare and set. So we do a comparison and then a set. I feel like these should be like x86, 64 specific enums as well. I think I talked about that though at some point. The right-hand side was to trick the register allocator into realizing that div interferes with RDX. It's going well. No, I'm just messing with you. So it seems like that's what red should do. But if right-hand side did that, then effectively if the right-hand side is set to RDX, it's saying, hey, we use RDX as well as the right-hand side. So we switch on value type. The right-hand side should be what? Whatever it is here, which is whatever it is here. Expression, children, next child, result. So this would be some IR instruction that would load this right-hand side. And by the time we get here, we move the right-hand side to the left-hand side because the left-hand side has been moved into racks. That's valid. The right-hand side does not exist. But to try and trick the register allocator, apparently, we say, hey, it probably uses RDX or it uses racks. And this is to let the allocator know this instruction clobbers. Yeah, but then... So we're setting the right-hand side to literally just the result of this ternary operator, which is just an enum. So div right somehow goes from a value pointer to an enum. I'm starting to understand the issue. How is this allowed? What is div right? Div is a value. What's on the right side of a div? Right-hand side is a value, right is a register. Ooh, okay. That's confusing. Why is right, left and right registers? Told you the value struct was jank. You were correct. What? So this must be to represent a one address instruction that clobbers a register very specifically. There's really no other use for the structure, which is just a little odd. Why is this needed in this way? It's starting to dawn on you why I called this one of the most abominable structs I've ever written. It definitely is. This doesn't make any sense, right? It's okay, because you're dealing with stuff that's so complex. Just keeping it all in your head is a challenge, let alone doing it correctly and writing it down. So, it's not like I fault you for it, but you are correct. This struct is horrible. It started off so innocent, but then it's just an abuse. It's an abuse of a tagged union at this point. And then this says used by the backend, more specifically the register allocator. So the register allocator, if they interfere, where even is that? Is checking whether V yeah, this doesn't, I'm starting to get it. I'm starting to get it. This is broken. Okay. So it seems like the issue is that, well, there's many issues because it's a work in progress, but it seems like the main issue lies in the fact that registers are kind of being mixed with values. That should be WRMI equals 1. WRMWI I equals 1. I, not vreg. Ooh, so this should probably also be I. Interesting. We're gonna try it. If it works, that'd be sweet. Web 4 interferes with nothing. No, it's probably fine. Web 4 may have changed. Web 4 is R11, that's the copy. See, so the result of div has kind of been lost. The value of div, I should say. Like, when is this ever... What has this? There is no value corresponding to this, which seems... But there is, because it's here. So, Web 4... Interesting. Web 2 interferes with Web 1. Web 3 interferes with Web 1. Web 2 is R13. R13 becomes alive here. Web 1 is R14. That becomes alive here, and then we use R13. So the fact that the definition comes between the use means, hey, these interfere. These interfere. That's valid. So we can do web to web now. We're still not getting any register web interference, but we're closer. We're closer. How beautiful is that? MYE. At least that part is right, lol. Exactly. It's like, well, it's not right overall, but we won the battle. You know what I mean? The war, still working on it, but we won the battle. Okay. There's now 8 webs. There has been 8 webs. Okay, that's much better. This is starting to look a little... Yeah, it's the same. But now web 5 and web 4. So web 4 is just R11. R11 is never used. R5 is R10. What? So R10 and R11 somehow interfere because R10 is not used, which means that since we're not doing our unused checks, then this means that R11 is technically between the definition, or the definition of R11 is between R10 and the use of R10, which is never. So likely R10 and R11 are not actually interfering. Should they interfere? I don't think they should interfere. R11 shouldn't interfere with anything. No other virtual register. So R11, the fact that it is web 4, that kind of tracks. But then web 5 interferes with web 4, which doesn't make any sense that web 4 does not interfere with web 5. Right? So it's a little, I think that's just because of the zeros in the debug output. I think it might be because the div uses R10 and R11 uses R4, which is used in the div. So R4 used in the div. R11 uses R4. Div uses R10. R11 uses R4. Right. Which is used in the div. So maybe we don't need that right-hand side register clobbering at all, is what you're saying. No, but then that seems like this web of R11 should definitely contain... Oof. Oof. Sir 8 says, I'll have to think about that, but right now I kind of need a break from register allocation. All right. It's a good time to stop. We had a great time. We wrote a PDF which makes many senses and helps many a lots. So definitely check out this LaTeX form, this page, if you are interested. It is up on the GitHub. It's obviously not going to be 100% done. There's a lot of to-dos and like sections that are just stubs, like register allocation and variable liveness. However, there are some very useful diagrams of static single assignment, for example. So you can see a non-SSA and then convert it into SSA. And with SSA, we can basically guarantee that this value that's been computed already, we can not ever stomp on it or clobber it if it's going to be in use later. Perfect. Perfect, perfect. So effectively, I think tomorrow we should start writing about register allocation. And I'm just going to continue to try and understand and write about webs and interference matrices and start to try and understand what that is. I may write that in my off time tonight if I have the time, but I most likely won't because it's already 3 o'clock and I haven't done anything except this today. So, hooray. In any case, thank you everybody so much for watching. I haven't shouted myself out at all. So I'm going to take this time now and say, go check out my things. There are links that you can go click, and you should click them with your mouse. Check out the Fun Compiler main branch in the description below. Check out SirAid's branch, which we did a lot of work on, not work on today, but did a lot of exploring within today. Because he's working on this IR branch that we are most likely going to merge if it ever gets done. No, I'm just messing with you. There's no rush. But we are most likely going to merge it, unless I feel like I can take the ideas behind the IR branch and implement them in a cleaner way, but I very much doubt it. In any case, thank you so much for watching. Check out the GitHub down below. Along with that, there's a YouTube with all my previous broadcasts, and the best part of all is the Discord, where you can check out all sorts of things. You get announcements every time I go live. You can ask to join this group where you can, get notifications, get pinged every time I go live, which I recommend. Bring back Scheme, MIT, Lamau. But yeah, you can share your progress in the code review, you can get help, you can do whatever you'd like, as long as you're positive and nice. Keep that in mind throughout your life, and you will go far. Thank you for checking this out. Check the Discord out, be sure to join, check the GitHub out if you are interested. If you have enjoyed and greatly enjoyed at that, I would very much appreciate checking out the donation link down below. There's a big old donate button. Shout out to our most recent contributor, which is Snarlfurb, aka Nick. Shout out to Snarlfurb for being our most recent contributor, and RPWH for being our heaviest contributor with the most amount of money. So thank you. Thank you so much. Also, Sir Aid says, it really doesn't help that pretty much the only examples of Chaitin-Briggs graph coloring in the wild that I can base this on are the book I have, which isn't that detailed, and GCC and Clang probably. But the main file for GCC's RA alone is 6,000 lines of code. That's not too bad. I'll have to check out GCC's RA. Register allocation. I mean, 6,000 lines of code is effectively what I read from you today, right? I'm pretty sure I read 6,000 lines of code from you, so... It wasn't all on the register allocator, a lot of it's IR. But still, I think it's doable. I should check that out if I have time. Thank you so much for pointing me to that. King Buns says, thanks for the strum. Thank you for watching, King Buns. I hope you enjoyed. We did a technical one today, but it's just because our compiler's becoming more technical. And I'm trying to help everybody out, and hopefully everybody can continue to understand how this works and the overall what the code even does, right? Because that's kind of the main point, is understanding why all this even needs to happen. King Buns says, I enjoyed and learned quite a bit. Thank you so much, King Buns. That makes me so happy to hear that. Because it means that me sitting here for 6 hours wasn't all entirely useless. King Buns says, I will provide any feedback on that tech doc. That'd be awesome, yeah. It's very likely there are portions that just skip to the next thing without talking about it properly, or maybe we use some vocabulary that we didn't mention what it means, so all of these could be issues, and I would love to hear them. Thank you so much, King Buns. Thank you so much, Sir Aid, for hanging out today and helping me understand this incredible branch that is incredibly complicated. But it's definitely worth it, because it will... I don't know if it's worth it. I think we should just stick with an AST. And if it was just me, we would. We would just reorganize the AST into a new thing. And then we'd do register allocation the exact same way we did before, because it's really not an issue. And then with like WebAssembly, it really wouldn't be an issue, because there are no registers, so you don't have to allocate anything. How beautiful is that? Other than that, I think we're good. I think we are good. It has been a fun time learning all this new stuff, and I hope you learned along with me. I will see you in the next video, and yeah, be sure to check out all those links down below, and check out any previous broadcasts if you're interested in this sort of thing. Be sure to follow on Twitch if you want to get notified from them as well, but they don't do it every time, so join the Discord if you truly want notified every time. But yeah, with that, thank you so much, and I'll see you next time. Bye, everybody. I love you. Love you. Bye. Bye, Mom. Bye, Dad. Bye, house. Bye, world. Bye, Earth. Bye, space. Saraid says, ta-da, as always. See you, Saraid. Thanks for hanging out. I'll see you when that register allocator is done tomorrow. No, I'm just kidding. I'm messing with you. Any pace that you want. Even if it's a week, as long as we can keep making content and keep talking about it, I don't care. See you next time. Bye bye.